Hey, attendance முக்கியமா? நாளைக்கு பார்ட்டிசிபேட் பண்றவங்க attendance முக்கியமா? வேற attendance முக்கியமா? ஓ, போட்டிருக்காங்க.
Good morning once again. Thank you for your patience. We are thrilled to officially start today's workshop on implementing AI agents, an area that is rapidly shaping the future of artificial intelligence. Without further ado, let me introduce our esteemed speakers for this session. We are honored to have Mr. Sachith Gunasekara and Ms. Hansa Naurunna, Associate Machine Learning Engineers at Search Global, joining us. They will share their expertise on implementing AI agents and guide us through the latest techniques and best practices. Please join me in welcoming Mr. Sachith Gunasekara and Ms. Hansa Naurunna. Over to you.
Thank you, Amra. So I see that the participants are still joining in, but I guess we can get started, right? Can someone please confirm if my screen is clearly visible and you can hear me?
Yeah, we can see it, Sajid.
Awesome. Right. All right. So before we really get into the hard stuff of implementing AI agents and really what sort of frameworks and technologies out there that you can use in your projects day to day and what really goes under the hood, I guess we could first understand what AI agents are and what they really mean in a context of in technological stance at least. So once again, before I go into AI agents, really, just let me give you like 1 or 2 minutes just to absorb what you see on the screen right here. So I've included an image on the right. So I would give you like 1 or 2 minutes, take a look at this timeline. And I've got some few questions for you before we get into the session. So go ahead and just take a look at it. Right, so I think that's plenty of time. So can I see a show of hands if you recognize at least 2 of the items that you see in this timeline? Just at least 2, if you recognize it, can I see a show of hands, please? And if you do recognize them, you can go ahead and type in the chat and tell me what you really recognize and if anything's new. I would like this to be as interactive as possible. We're going to be here for 2.5 hours, and I just don't want to end up speaking on my own. It's going to be so interactive, and you can just type in interrupt me whenever you feel it's necessary to ask me any questions. So I just see some hands raising up. Is it just one? Okay, that's two. All right. So I guess, I mean, you can go ahead and type in whatever you feel is necessary to see if you identify two of these. So I think the most common thing that you'll see here is a lot of GPT being mentioned all around the timeline, mainly because its user friendliness and the powerful capabilities that it performs, right? So what I've listed out here is just a list of language models and tools that came around it throughout the years, right? So starting from 2020, even way before 2022, till now. So there's like a bunch of different things that came around it. So we're not going to be talking just about large language models today. We're going to be talking about AI agents. So one other question that I would like to ask is, you can put your hands down because there's going to be another question for you to raise your hands. So when you hear the term AI agents, do you immediately think of something like ChatGPT, Bard, or something like that? Can I see a show of hands if that's what comes to mind first when you hear the term AI agents? Okay, so there's no hands raising up. So ChatGPT and Bard are not one of the terms that comes into mind for you guys when you hear AI agents. So that's quite debatable if you think about it. But ChatGPT can be an AI agent if you think about it in different ways, but then again, not. Right. So there's like a bunch of different arguments going on what AI agents are and what really goes behind them. So let's really drill down fundamentally into it, as well as theoretically applying it. We'll see how we can apply it in different settings. So we'll be talking a lot about a few frameworks that are out there that you can use to build AI agents, and then what sort of functionalities that they have. And at the end of the session, we've also planned like an extensive from scratch project which Hansa will be implementing actually. And you will really understand what's going on inside these AI agents and what really makes them tick and what sort of customizations you can do to make it really your own, right? So introducing ourselves, I'm Sachith Gunasekara, and I work at Search Global as an associate machine learning engineer. So I joined Search as an intern about a year and a half ago. So sometime around March last year. I joined as a data science engineer, and I work, data science intern. And I mainly work on research projects, mainly related to large language models and their efficiency. So you could say that I work on deep learning research. So
Oh, yeah, let me introduce myself also. So I'm Hansa, and I also kind of joined with Sachit, so kind of the same story there. But I kind of mostly work on kind of the application side of things, so just working with LLMs and like stuff to actually create agents and like do that entire thing, like chatbots, and there's like so many use cases, right? So various applications around that. A little bit of stuff around computer vision, but just LLMs and agents. Yeah. So back over to Sachin.
So you could say that Hansa is the more experienced AI implementation agent here. Okay, so let's move on. Right. Now, since we have quite a lot of members in the audience, I would like to hear, you can unmute yourself or you could type it in the chat, whatever is comfortable for you guys. Can you give me a few examples of what you think AI agents are? So like I said, before we go implementing AI agents all together, we need to know what they are and what sort of functionalities and what really makes them AI agents and what really what components make up AI agents. So I would like to hear a few examples from you guys of what AI agents are. Anything, any AI agent that comes to your mind. There's no such thing as a wrong answer or right answer. And if you think it's an AI agent, I would like to hear some. You can go ahead and, like I said, in the chat, or maybe you can just unmute yourself and talk. It's fine. Let's make this interactive as possible. Oh, it's going to be boring for 2.5 hours. Any example?
I think it's easier if someone raises their hand and then we pick whoever raises their hand. Yeah.
Okay, I think that sounds much more intuitive. So if you know an AI agent, can you raise your hand? Like, raise your hand up if you know an example of an AI agent, just one. Okay. All right. Okay, so I mean, I'm gonna tell your name. I mean, I see 2 hands raising up. I'm just gonna say your name. You can unmute yourself, or you can just type it in the chat. It's up to you. All right. So I see 3393 Mazar. Can you give me an example?
Yeah, specifically, I would say React agents, where it's reasoning and action.
Okay. Okay, good. Did I hear an example of an AI agent there?
It's more like a framework we use for AI agents, but I would say like it's a very broad topic. Like we can't actually like frame. There are a lot of AI agents specifically, but if you are like specifically speaking about the LLM agents, yeah, we can bring some examples there. But AI agents is anything which solves a specific task with the help of its environment, like maybe some tools or functions, and then kind of to solve a specific problem. So even ChatGPT can be an AI agent because it solves a specific problem.
Right. Yeah. I mean, I think that sums up about AI agents. That's quite a good definition. But now, if you think about something that solves a particular task, maybe a software can be something that solves a particular task too, right? Maybe something like Windows is an operating system. It solves the task of manipulating your computer. But what really makes that an AI agent, right? Okay, so but what you said was really thank you. Your name is Masa, right?
Okay. Yes.
Yes. Thank you, Masa. That was really that was kind of the answer that I was expecting, right? If you think about AI agents and if you drill them, I mean, if you focus on the smaller part where you talk about LLM agents, then ChatGPT is an LLM agent. But is that what an AI agent is, right? So you talked about something that reasons and acts, that those are called React agents. And I see that you have some experience with implementing AI agents. So that's really a good way to look at AI agents. And if we look at some examples that I've aligned today, maybe you can accept that a self-driving car is an AI agent, right? So if we really look into what a self-driving car does, just give me a moment, right? So if you look at what a self-driving car does, is it uses different sensors, right? Like LiDAR sensors, cameras, and maybe even radar to look at its environment, and it monitors the surroundings, right? It can look into different objects, different vehicles that are moving around, humans that are walking on the pedestrians, and even maybe monitor its navigation route on where the destination should be, right? So it monitors the surroundings, and then it determines the optimal route that it needs to take, right? And it reacts based on obstacles in real time. Like if you're driving yourself, and if it's not a self-driving car, if you're driving on the road, it's really crucial that you look at the road, right? You need to be alert whether people are crossing the road, whether there are vehicles coming in from various directions. If it's in Sri Lanka, you know that there's going to be different vehicles coming in from all directions. So the self-driving car, probably that's one of the reasons we don't have self-driving cars in Sri Lanka, because it really needs to be highly alert and determine the optimal route and not hit anything on its path. So it determines the route as well as it reacts to obstacles in real time. And then based on these sort of actions that it thinks that it needs to do, based on the data that it has or the data that it gathers, as well as the set of AI algorithms that work underneath, it will then control the steering as well as the acceleration and braking to navigate safely without hitting anything in its path, and then try to get to the destination as safely as possible for the passengers inside the car, as well as the pedestrians outside and public objects as well. So another example could be a stock market analyst, right? If you think about a stock market analyst, what it does is it tracks real-time financial data from maybe if it is stock data, or maybe cryptocurrency, or whatever financial market it is. It analyzes the charts. It looks at it tracks all the data that goes on, whether the price fluctuations are significant, or whatever data it can gather. And that's pretty much a stock market analyst job. It tracks all of those, as well as look at the market indicators, maybe even look at the news, because news does affect the stock market. So it can track all of this information, and then it analyzes the trends, right? It analyzes all of these trends in the charts and the news, and try to predict the stock movements based on the information that it has. So that's what the stock market analyst does. Once it has decided on whether the stock movements are going to be going up or down, then it will execute a trade and generate investment recommendations based on the information that it has. So now you see that when I started about AI agents, I'm not simply going to, like Mazahir has said, we're not going to be simply talking about LLM agents, right? So AI agents, they need to have some specific characteristics in them to be called an AI agent. Don't worry, we'll be implementing LLM-based agents at the end of this session. But I just want to tell you what AI agents are and how you can really make an AI agent, right? To have the different components in it. So some other examples could be like a medical diagnostic agent, where it gathers information on patient data, and it tries to identify different look at the different charts. I'm not good in medicine, but maybe try to identify all the different components of the medicine and decide on certain actions that it can take, whether the patient needs a surgery or not. Maybe those decisions can be made by a medical diagnostic agent looking at the charts. And even a robotic vacuum cleaner can be an AI agent, because it scans its surroundings and it identifies objects, and then it decides which direction it needs to go, identify whether it has cleaned its current location, or whether it needs to go to the right or left, or whether it can move forward. So those decisions are made and it acts accordingly, right? So it reasons and acts. It's some sort of a react agent, like Mazahir said. Now, what's common in these, right? Now, if we're talking about an AI agent, we need to know what's common. Now, when we focused on a self-driving car, we said it monitors its environment. It determines the optimal route that it needs to take without hitting any passengers or vehicles or any other objects in its path. And then it controls the steering, and then it navigates to its destination safely. So those are the three things that a self-driving car does, right? So a stock market analyst, on the other hand, it tracks the information, tracks the chart data, financial information, analyzes it, and finds and tries to look at all the information that it has to predict where the stock movements are going to go, and then execute that trade once it reasons out, once it determines the path that the chart might go. So if we think about, like, if we think now, I just mentioned that these are examples of AI agents. And if we think about AI agents in general, there are three components, right? And that's why I have put them into three separate columns. There's like three components that really make AI agents. You can call them AI agents, right? You can call an agent an AI agent when it has these three components, right? So the first is perception. So it needs to perceive its environment, right? It needs to gather information from its environment, and then it needs to make decisions based on the environment that it, based on the gathered data, as well as the information and other algorithms that it works on. It needs to make decisions and act accordingly, right? So these are the three things that makes an agent an AI agent. So with that, since we've drilled down from an example point of view, now the definition of AI agent is going to be much more intuitive, right? So an AI agent, like, I'm just going to read this out, and then you probably will get it on your own, since you now have what makes an agent an AI agent. So an AI agent is an intelligent system that perceives its environment through inputs, decides on actions based on the data that it gathered, as well as the algorithms that it has underneath for that particular AI agent, and acts upon the environment with tools available to it to achieve specific goals, right? So I've highlighted some of the important, like, the keywords in this definition, and we can summarize it in the one that you see below, right? So an AI agent is an intelligent system that perceives its environment, decides on actions, and acts upon the environment to achieve specific goals, right? So this is like the definition of AI agent. I didn't want to just give you the definition from the start and tell you to memorize it at stretch. I just wanted you to be able to look at any agent and see if it has these three components, and then identify whether it's an AI agent, right? So now this is where an AI agent can be differentiated from maybe a software agent, where it actually perceives its environment, but the actions that it decides to take is sort of predetermined. It's not intelligent, and the way that it acts upon the environment can be different. So let's stick to the AI agent definition and know that there's three components that really makes it an AI agent. It needs to perceive its environment, decide on the actions based on data and intelligent algorithms, and act upon the environment with tools available. Okay. So now, then, so we know that AI agents are defined like we defined earlier. So what can we talk about LLM agents then? Like, what's the difference between LLM agents from AI agents? Are they different, or are they the same thing? Or is there any relationship that LLM agents has with AI agents? Can I see if maybe let's start with a show of hands. If you think LLM agents are the same thing as AI agents. Okay. Any others? So the question is, do you think that LLM agents are the same thing as AI agents? Do you think so? If so, you can raise your hand. And if not, I would like to see why they are not. I mean, I'm going to get to it, but I would like to see some interaction as well. Okay. So, okay, so I see that there's two people from the audience that claims that LLM agents are the same thing as AI agents. So it's pretty much a little bit different. not the same thing, but there is some sort of relationship, right? Okay, you guys can put your hands down. So I'm not saying they're the same thing. There's a relationship between LLM agents and AI agents, and we'll get to it. But when we talk about LLM agents, what we are really talking about is LLM-based agents, right? So now what's the difference? It's just that I added another word in between LLM and agent. So when we talk about LLM-based agents, we are talking about an AI agent that has an LLM in its workflow at least, right? And we know that large language models are quite intelligent these days, but it's intelligent in terms of it's able to produce text. All right, it's able to produce text and simulate an intelligent behavior, right? And with things like context learning, in context learning, we've been able to align large language models to sort of reason out, right? It has the ability to reason out based on different conditions and different settings and decide on certain actions. So, and a large language model or an LLM can sort of act as a brain, like an intelligent brain, like a human, because we can really talk to it as a human. We can sort of make it, we can customize it to our needs, right? So if you think about an LLM, right, on its own, you can go ahead and feed it in a prompt, and then you can get an answer. And that's all that an LLM does, right? You feed it a prompt, and it gives you an answer. And then you can go ahead and take that answer and then sort of maybe align like a conversational format. And then you can have context of your previous conversations, much like what ChatGPT does, right? You go ahead and communicate with it, and then it will remember your previous conversations, and then you can have like a seamless conversation. But that's all that an LLM does, right? You feed it a prompt, at least an instruction-tuned LLM. You feed it a prompt, and then it gives you an answer. But it really doesn't have like additional context. It doesn't have information. If you think about an LLM in like out of the box without anything else, it doesn't have information that is out there that occurs day to day on a daily basis, like news, maybe stock information, whatever. It doesn't have access to those information because it's just producing text based on your prompt, right? And you might have noticed this with ChatGPT, where when you ask something current, it will probably tell you that its knowledge is cut off from this date, right? So this is not anything new, since we've been using ChatGPT for a very long time. These are things that we already know. And so that's where you can improve the LLM with RAG, right? So RAG is we're not going to be talking about RAG specifically here. So RAG is just retrieval augmented generation, where based on your prompt, right, you can have your intelligent system. Now, technically, your LLM is not able to get that information for you, right? So there's different other processes that you do to get relevant information to your prompt. So you might have a database of information, or maybe you can implement, you can have like a set of documents, maybe databases, or maybe like CSV files, whatever, right? You can have those set of documents that you have, and then with what RAG does is you bring information that is relevant to your prompt from the set of the information that you have, and then you augment your prompt with the additional context, and that's why we call it, we retrieve information from a database, we augment your prompt, and then you pass it through the LLM to get an answer. So now the LLM is quite current. It has information that it was additionally not trained on, and it can give you answers based on this additional augmented context that we gave into the prompt, right? So that's what retrieval augmented generation does. So now, talking about an agent. Now, what makes an agent different from just a simple RAG application? What a RAG application does is bring information, augment the prompt, and generate an answer. But with an agent, when we feed in a prompt, it has different tools that it can, different things that it can do, different like functionalities that it have. Like it can have access to a memory, maybe like I said. So ChatGPT is sort of an agent, like Mazhar previously mentioned, because it has access to a memory by conversation formats, but it's quite different. We'll get into it later on. But when we're talking about an agent in particularly about an agent, an LLM-based agent, when you feed in a prompt, it might have access to things that you said previously, things that you said earlier on, maybe in a different conversation. It might have that memory, and then it has a set of reasoning capabilities to get to an answer. And it's not just generating an answer to your prompt; it's generating actions that can act upon the environment that it's working on. We'll see examples of this, and we'll also implement it later on. But you see that how an LLM has evolved throughout the stages from a simple RAG application towards an LLM agent, right? And that's sort of what you need to understand about LLM agents, OLLM-based agents, right? At least for this session. So we are going to be talking about LLM agents, yes. So we are going to use the term LLM agent, LLM-based agent, or AI agent interchangeably, right? So when I talk about those three terms, I'm simply talking about LLM-based agents. So an LLM agent, like I said, is there a relationship? So an LLM agent is just a type of an AI agent, right? So an AI agent has three components. So LLM agent is just one single type of an AI agent. And that's sort of the relationship that LLM agents has with AI agents, that it is just a subset of AI agents. Okay, so then looking at the image on the right, now this is a much more complex diagram than the one that I had in the previous slide. So when you talk about an LLM agent or AI agent, based on whatever prompt that the user asks. Now, note that when you are talking with an AI agent, you're not just asking it to give you you're not just asking it to give an answer to your response. Maybe you're asking it to do something, right? Maybe you're asking it to maybe if it's connected to your house, and maybe you're asking it to turn off the lights, or maybe you're asking it to do a series of things. And you can do multiple things with AI agents, with LLMs these days. And when you feed it a prompt, now that it has the ability to understand your prompt, in no matter what you type in. Modern LLMs has the ability to understand what you're talking about, the context that you're talking about, and then it understands when it needs to do something, and it understands when you need to retrieve other information, right? So there is a retrieval augmented part as well. It will bring relevant information when it needs to, and you can communicate with data sources. You can communicate with different data sources like SQL or documents, CSV, like I said, and you can bring relevant information that you need. And then maybe if you are working now, if I talk about an example for this document data, if this is an AI agent that we work specifically for, let's say, a legal case, maybe when you ask like a legal question, whether it's legal to wander around the streets at night after 12 in some area, maybe you need to look at the information that is out there, because an LLM does not know it out of the box. Maybe you have a set of documents with the specific rules. You can retrieve any information relevant to your prompt and then augment your answer and then it's like a simple RAG, but it works under the hood. And if let's say we're talking about like a data analyst, you can maybe ask it to analyze a certain set of trends, and then it will decide a series of actions that it need to do. And since now we know that LLMs are just generating text, and the way that we get it to maybe like draw charts, or maybe if you've experimented with machine learning, you know that we need to draw different charts using pandas and other libraries. So what we can get the LLM to do is generate code that does that particular task. So the AI agent decides what it needs to do, right? So that's the LLM. It will generate a series of code that it needs to run, and then the AI agent has access to a code executor where you can execute that code and generate some output. And then based on those, maybe based on that information that it has gathered, it can generate task outputs to do, right? So we have a small demo on. So Hansa will be showing you a small demo on how you can on what actually how you can get a simple LLM agent to do something as simple as doing like maybe sending a text message or something. So Hansa has a demo ready for you. And before I hand over the session to Hansa to continue with the second part of this session, now we earlier mentioned that AI agent has the perception, has the ability to make decisions, and it takes actions accordingly. So when you talk about an LLM agent, the perception that the AI agent has is it receives textual input into the agent, and to make decisions, it generates, once again, it uses an LLM to be intelligent. So what it does is, based on a set of based on a context that we have given on how the agent needs to behave, it will generate text based on the input, and then as well as the context that we have given, right? And the actions that needs to be taken will the LLM agent will produce these actions, typically in a JSON format, right? So this part will be demonstrated to you by Hansa. So before we move on to the architecture of AI agents and a demo on that, I would like to ask the audience if you guys have any questions that you need to ask before we move out. If there's anything that you need to clarify, or if something that was not clear up until this point.
Sachit, I think there's one question in the comments.
Oh, really? Hold on. Yes, right. So exactly. So I didn't see this. Sorry. So okay, there's another Sachit who's mentioned that yes, designed for the specific task to understand natural language. So I'm not. I really didn't see this. I'm not sure in which context this was typed in, but for the question, for Ahmed's question, yes, LLM agent is a subset of an AI agent. Yes, it's just a subset, like I mentioned earlier. Any other questions? So Sachit, if you have like a follow-up question on the previous one, sorry, I missed your text earlier. You can probably, if you can unmute yourself and then talk, that'd be great. But is there like a follow-up thing that you wanted to talk about? All righty. Yes, Maza, go ahead. You can unmute yourself.
Yes, just for the sake of like LLM agents, is it more like where we use it more to optimize or automate certain workflows, which are like predefined in terms of what steps it would take? For example, as a stock market analysis, it's more defined where we understand, okay, these are things like a person would take to analyze the stock market. So we kind of, plan or structure the agent in such a way that it has the access to those data and information, and use that to use a plan, and then use that data to, take some action in terms of whether to maybe just even provide the information to the user, saying whether to buy the stock at this rate or not. So is it more like predefined task, or we can that's certain level of dynamic nature? But do you think using LLM agents in a way where we kind of have a lot of dynamic nature would work, or is it more predefined task which it can help you people a lot in terms of reliability and efficiency?
Right. So good question. So it's not predefined, right? And that's basically the whole point of getting AI agents into technological settings, right? So if you have predefined settings on how you need to, not always, right? But you can always augment your agent with like a series of, maybe you can give it a series of thought patterns, and then ask it, okay, this is the way that you reason out. But when it comes to something like a stock market agent, we discussed earlier, you probably wouldn't like specifically put it strictly to a frame and ask it make decisions based on this framework, right? we would obviously allow it to have a like sort of dynamic nature, have more freedom in making decisions, but it needs to have some sort of integrity when it comes to making decisions, right? So maybe this particular LLM agent is either fine-tuned for this stock market agent scenario, where it has learned out based on these type of information, based on these type of stock market data. Maybe, okay, if the charts look like this, maybe I need to make prediction based on that. So there would be a level of expertise that these models need to have on their own, either by fine tuning or some other manner. It depends on your task. But yes, it does have you're not going to have a predefined set of steps always by asking it to do it in this manner, right? You would give it the freedom to decide based on the information that it has, but knowing that this model has the expertise or it has the integrity to make decisions for that particular setting. Does that make sense to you?
Cool. I was talking more like the workflows. So, for example, we have these email writing agents, which are very commonly seen people are using, but they kind of have a fixed set of workflow. That's what I was mentioning, a predefined workflow, where they kind of write an email, then critique, and then rewrite it, and then kind of there's a workflow we as humans define to make sure, okay, this is the right approach for as a human I would take to do kind of like task like this.
Exactly. Like for general purpose settings where like email writing or essay writing, content writing, you would obviously have that sort of setting where you would ask it to first, okay, go ahead and generate a content, and then, like you said, maybe critique on it, identify weak points in it. You can have a series of predetermined steps. Yes, that's pretty fair.
So my question was more like these workflows, actually they have their dynamic nature based on the data and everything. Their decisions, the planning, of course it would change, but in terms of the predefines of the workflow, do you think giving a dynamic nature there would be much more preferred? I mean, like, will LLMs work in a good manner when we give that level of dynamic nature to it, because we are like having a multiple agents if in a scenario, but having a like kind of a predefined workflow, would it make more accurate and reliability wise? So that was the like main question there.
Right.
So whether to focus on predefined to increase the accuracy and then reliability, or to make use of the agents because of their thinking nature to generate a very good answer, like for example something a human can't actually think of, something like that.
Right. So Hansa, do you want to add in something? Or
Yeah, just wanted to like add that maybe if you want like a sequence of things to happen, right, you could use something like a graph or something like that. But in the case that you want to use like an agent to do something like this, there's something called SOPs, which is like standard operating procedures. And these are usually, I saw a few like SOP type things on a few like code execution papers, but the idea is that you'd outline like a standard procedure for certain things. Like in your case, you were saying something like email writing. So you'd like write the email, then you'd do a critique, and then do the entire thing, right? So you'd have like a standard operating procedure that you define, and then it would kind of go through step by step using the tools and do the entire thing. But if you want, like if you have a very concrete like steps, right? You could definitely use like a graph, like line graph or something like that. And that's probably the best way you can like create these workflows, or just give a standard operating procedure to an agent and they'll roughly follow it. Does that help? Or what do you think?
Yeah, kind of. So I was wondering to know, like, if we are like using that kind of standard workflows, does it limit the agent, or we should like kind of give it the freedom to generate the plan and like that level of freedom? Like, does it work more than like, because LLMs are like there's some level of probability, like it's end of the day, it's a probability model. So
yeah. Actually, if you combine the two, right? So let's say you have like a general agent that's more of like a dispatcher type thing, and you have like sub agents that are like more specialized, then you could do something like that. So the sub agents would kind of be like more related to kind of like email writing or critiquing or something like that. So that would be kind of a multi-agent type thing, and those would also have like a standard operating procedure, like that's like very concrete to them. And yeah, using a workflow like that, you don't have to technically limit yourself, because like the dispatcher agent could be like, so right now I need to write an email. Let me send that off to email guy. And then email guy kind of does all of that. And he's very specialized in doing emails, right? So it does the email, sends it back to dispatcher. Dispatcher's like, okay, I did this work, and then sends it back to the user, and user's happy, right? Something like that, right? It depends.
Yes,
You
yes.
can make it any way.
It depends a lot in what we are trying to achieve as well, right?
Mhm.
Thank you. Thank
Yeah,
you.
it depends on the task, yes. So
Yeah.
like Hansa mentioned, you can always have a human in the loop, see whether there's always like an agreement, right?
No, sure. Thanks a lot.
Any other questions?
Excuse me, I've got a question. I don't know whether I'm audible.
Yes, you are a little bit faint, but we can hear you.
Yeah, actually, I'm at the library. I can speak much louder. All right.
Okay.
Yeah, it's just a question, not regarding the, the contest or something. If the AI agent is not limited or not scoped to a predefined data, can it act like a reinforcement learning, something trial and error or something like that? Because it should be aware of the environment, right? As you said.
Well, you could do that. So yes, that's completely fine. See, like you said, see how it works on the environment, and see how probably the person who's looking at it maybe have a different RL model, looking at the actions that the model takes in, and then refine tune the model back. That's perfectly fine in most cases. But when in scenarios where we are talking about where we build LLM agents, yes, that's possible. But in most scenarios, when we want to build using LLM agents, the component of using reinforcement learning is a little bit, a little bit thin, but it's possible, yes.
All right. Thank you.
All right. If there's any other questions, we can answer them, or or maybe we can proceed with the session, right, Hansa?
Yeah, definitely.
Okay. If you have any other questions, go ahead and put them in the chat, and we can answer them during the next break. So I'm going to stop my share and hand it over to Hans.
Okay, give me 1 second. Let me share my screen. Okay, since this is the first time, I need to allow, I think it's asking for permission. Okay, quit and reopen. Okay, I think I had to leave the meeting, and I'll be back. Give me 1 second. You guys can see me, right? Okay, I'm back. Give me 1 second. Okay, I can share my screen now. It really odd. Thought they'd get permission before doing anything. Okay. Wait, give me 1 second. You guys can see my screen, right? Sachith?
Yes, Hansa.
Okay, great. Let me just go to where Sachith stopped. It's around here, the transition for a slide is not there, but I'll just start from here. Okay, slideshow. Okay, so Sachit basically explained like an introduction to what an AI agent is and like the definition of like an AI agent and like an LLM agent and stuff. So from there, we're going to be diving into more of a AI architecture type thing, not AI, I mean like LLM agent architecture type thing, right? So LLMs, when it comes to like communication, what it can do is basically just generate tokens, right? Generate words, basically. That's the only way it can kind of communicate. And when we think of like an agent kind of does a lot of actions and manipulating the environment and things like that, right? So how do we kind of turn these words that an AI agent kind of like says, like an LLM says, into like actions, right? So, okay, the only way LLM agents can communicate is through words. So how do we turn them into actions? In this small diagram here, you can kind of see like an LLM, it's sending instructions. And then there's this agent framework that kind of takes those instructions, which is basically the words that the LLMs produce, and kind of converts them into actions. So over here, you can, you know, control a robotic arm, play Minecraft if it's really fine-tuned for that. And then that feedback is sent back to the agent and then back to the LLM as like a response type thing. So that is kind of the most basic type of agent, which is the React agent. We'll basically only be talking about the React agent for like this presentation. So just React basically. Let's go to the next slide. So how do we kind of turn these words into actions? So like, let's say I'm an AI agent, right? I'm just communicating words and stuff. And let's say Sachit is like the framework, AI framework, that's actually like turning these words into actions. So if I want to tell Sachit to actually like turn my words into actions, I'm basically delegating it, right? So let's say I want to do something like communicate from the user to like tell their mom that they'll be home late or something like that, right? So I could say something like, hey Sachit, could you tell that the user's mom that they're going to be home late? And then Sachit will basically do all the actions and like do the delegation part, right? So he'll basically call up the user's mom and say, oh, your son's going to be home late or your daughter's going to be home late. And yeah, so that delegation part is going to be completely to like the AI framework, like the agent framework. Okay, so taking a look at this example, we say something like, can you please call the user's mom and tell I'll be home late or something like that. And then the actions will be calls mom says I'll be home late. And then, okay, we can make this like a bit more explicit, right? So if I'm just talking, it's a bit hard to kind of understand like for a system, right? Like when it's actions, when it's actually instructions, or like just me talking, right? So to Sachit, I'm going to start, before I like give instructions, I'm just going to say something like a keyword like action, right? Over here, you can see like in text, it's like the action I want to perform, it's in this tag. So whenever I like say this tag like out loud, it's basically saying I'm going to like give you instructions now. And once I'm like say the end tag, that's like the end of the instructions. So it's going to be like I say, okay, instructions start now, the quotes, and then I say, can you tell the user's mom that he'll be home late? Oh, yeah. And then I'll finish it by saying instructions end or something like that. And it's more clear to Sachit that that's the instructions that he needs to do, right? So, you know, we're communicating with computers and it's just code like all the time, right? So natural language is probably not the best way to go, because like communication to computers through natural language is a bit difficult. So we're going to be a bit more explicit and say like within these like instruction tags, we're going to say something like the specific action I want to do, which is like call, right? And then who I want to call. So it'd be something like mom. And then the message will be like, I'll be home. So it's like very explicit, and you could take something like this and parse it and actually like use it in a function. So that's kind of how that delegation part would kind of work. So I guess like the goal would be to kind of get the LLM to produce something like this, to actually give instructions to the framework to actually like do this, right? Because then the framework sees, oh, it's an action now. Okay, I need to do a function call and give that response back. So this is how it like explicitly knows. So, okay, let's take a look at some of the code behind this, like a small like, example. Okay, this thing is in the way. I don't think you guys can see it. Okay, reconnect.
Well, Hansa, we can see it, by the way. Your top bar is not visible, so you can just go ahead and.
Okay, yeah. So let me just walk through the example like really quickly. So we're using something called Light LLM here. So Light LLM is basically like a small library that lets us connect to LLMs a bit agnostically. So you're not like kind of vendor locked to anything. So you don't have to use like Anthropic or OpenAI or anything like that. You can use anything. So we're over here, we're gonna define like a few like models, like the roles and the models, and also like the message schemas and stuff, just to kind of help us later down the line when we actually write the code. Okay, so let's actually go through the system prompt before anything else, like before looking at any of the code, right? Okay, so let's say we're basically telling the agent, you're a personal assistant, you help people with their daily tasks, and they might ask you to do actions, right? So like we're now telling it how to actually like do an action. Like if you were to tell me how to specifically like do things, kind of the rules of like how to actually make like an instruction, right? Like or an action. So we're giving it an example of like, this is how you'd actually create an action. So we say within action tags, you need to do something like this, where you have the action and then the parameters, and then to whom you're sending it to, and then the message. And this is the text message kind of action, right? So like over here, down here, we're telling it, so you have access to this call action. And here's like an example of how to do a call action, right? And if we like really want to, like in the future, you could have like additional actions over here. Like, let's say you could have something like another text action. And then in this text action, you could like define how you send the text. And we could add like over here. Oh, so now you have like a text action, right? Something like that. Let's maybe just leave that text action in there also. Like, let's say if it like, picks between calling and texting, right? So moving on, so just loading API keys over here. And then over here, like I actually have the code to actually do this completion. So we're importing Light LLM, then we are adding like the system prompt and like the messages. So we have the system prompt, and then we have like the message, which is like, can you tell my mom I'll be home soon? And then I'm giving her number. So it's not actually her number, it's my number. And then we have this Light LLM completion call, right? And then we have like the response that it's going to give. And then from that response, it's going to reply with like something like this, right? Because that's kind of word extraction like format that we're kind of expecting, right? So we can take that function call that it's kind of produced, and you can see that it wants to do a call action, and then it wants to call this number, and then the message is, I'll be home, right? Okay, so I don't want to run this directly because just want to have like a little bit of time between just showing this thing and actually making the action call. Down here, you can actually see like the actual logic to do the action, which is like you pass the like action and you actually get the action name and the parameters. And then if it is a call, we actually do like the calling logic. And this is like the calling logic. It's just HTTP like call to like a service that's running on my machine right now. So let me just run things. Don't know if it's connected. I think it's connected. So that ran. Let me just run all. Don't want it to run this one. So let me just run everything above this. Run. So it's full. I think at the end of the session, we'll like share all this code. Okay, so we kind of ran this little script here, and then we got the response. It's not printed, so let me just like quickly print this function call. So like from this message, like it just made this function call and it's to this number, right? So if we say like Sachith's number, we can just add that here and it would like change it. So let me just say like 2 or something. It would know like it needs to change the thing here, and then it changes to 2 because we tell it the number is different. We could even say something like call over here. So call phone numbers. Can you be home? Text her. Okay, actually it's texting. We actually want the call, right? Call her. So let's just run that here. And you can see it just changed from call. Okay, so I'm just going to change this back to 4, which is like my number. And this is the function call that it's producing. And so the agent framework takes this and actually like makes the function call, right? So I press this, it takes that thing it just generated, and then it runs it, right? And call initiated, I should be getting a call. Okay, let's see if I get a call. Okay, I'm getting a call. Can you guys see that? It says, yeah. Yeah, I guess you guys can see it. So you can see it, right?
Yeah. You just
Okay.
bring it a little bit to the top. You can see this. Yeah, we can see it.
It's like a phone call. Okay, I'm
I
just
think
gonna
it's
kill that.
better.
Yeah.
You better mention that there's like a different calling service that you have
Yeah.
initiated.
There's a calling service like on my machine, so when I make that thing, it'll like make the call. Yeah, so that's basically the words to actions like part that I wanted to show. Does anyone have like any questions so far about like the code or like words to actions, like what it means and stuff? Let me just open this up again. You guys can't see yourselves, right?
Don't worry about that. You don't see whatever's on Zoom on your end. And by the way, Hansa, I've also shared the notebook on the chat itself, so these guys can
Oh.
play.
You know, at the end of this session shall be shared, or like.
I see. Oh, hold on. Let me just.
So I don't mind just.
Hello, excuse me.
Yeah.
Yeah, I have a question regarding LLM, which means about ChatGPT. I'm curious about it. Maybe this is a silly question. We all say that ChatGPT is a LLM, which means language-based model. Then why do we actually get images from ChatGPT, generate images and videos or something like that?
You know, that is actually a perfect example of function calling. Because what actually happens is like ChatGPT doesn't actually have the ability to generate images. What it does is it calls the DALI API and then says this is what the user wants, and then sends in the user ID plus like the prompt and stuff, right? And then it generates image, right? And then in subsequent messages, it knows the previous like images that you generated and the user ID and the conversation and stuff. And DALL-E can like intelligently kind of generate images, like depending on like the function calls and stuff. So that's why like the images are kind of interconnected as well, like sometimes, because there's like a history there, probably some caching. So that's kind of the idea behind like LLMs being able to generate images. They don't actually generate images. It's just DALL-E.
Right, even I didn't expect that because we are using ChatGPT all this time, but we didn't know about it's connected to DALL-E for generating images.
Oh yeah. There is actually a paper that like is trying to actually create text and images. So there's like a diffusion model in the LLM, and then they're trying to create like images out of that as well. So I think in the future we'll probably have like diffusion models with LLMs, and they'll be like fused together and creating images and text. So yeah, so that's why you can't generate like diagrams and stuff, right? I'm not sure if you can, but even if they do, I don't think it's like that great. Because there's like no like huge connection there. Yeah, so I think that answers the question. Are there any other like questions? Trying to open this. Okay. I'll share the notebook at the end of the session. Okay, I think that is it for now. We'll move on to like the other stuff. Okay, let's open slideshow. So now we're kind of moving on to like what is a tool, because I didn't do like a really great job at explaining like what is a tool like during the words to action spot. So a tool is basically kind of like, it's literally a tool, right? Like this tool, for example, is a calling tool. So it has a name, so it's a calling tool, and the description is, if you call this tool, it will make a call. So initiates a call to a phone number, optionally schedules a call for a later time. And then you can see the parameters to actually execute this like tool call, right? So the properties, you can see schedule time is that's not really required. And then you can see asynchron is off. So that means it doesn't run asynchronously. Oh, wait, it went back a bit. Okay. And then over here in the running function here, you can actually define the code. And that's basically like what a like a tool is. External module or API that extends an AI's function beyond text generation. So function calls the mechanism that allows agents to invoke these tools or like functions for a specific task. And over here, you can kind of see an example, like a small diagram of like what actually happened, like during the words to actions thing, which is we have an LLM, it generates the text, it goes into the tool, like we do a tool call here, and then this is the code inside the tool. It connects to Twilio, and Twilio gives me a call. So tools can be anything. So that you can have web browsing tools, code execution tools, API integration tools. Like literally, if you can write it in Python, slap it on a tool and give it some parameters, it's a tool. So like you can turn on your neighbor's like TV if you have, somehow done like the code for that. Anything that can be written in code, it can be a tool. So moving on, like we'll kind of go away from tools for now, because I guess you guys have like an idea of like the tools and stuff, what tool is. The actual agent framework and like agent loops. So we didn't really discuss like how like agents can be autonomous and stuff, right? It's not just calling a tool, right? You need to kind of make that tool call, get that response back, and then from that you had to make decisions, and then from there you had to like decide if you want to talk to the user again, or do you want to make another tool call. And yeah, so all of that is kind of handled within like the agent framework. So in this like little like drawing here, you have like the user, it sends in a prompt, it could be anything. And then the agent framework kind of decides whether it needs to make a tool call. And then like, let's say it does make a tool call, it goes here, comes back, and then it decides, oh no, I need to make another tool call. So it just, that's the agent loop. Like it figures out what it needs to do next. And the driving mechanism for all these decisions is like the LLM. And like once it decides like what to do next, it might make another tool call, and then at the very end, it just sends it back to the user. You can see Light LLM is kind of like the provider agnostic framework that we're using to actually like abstract these away. So you can use OpenAI, Anthropic, Olama, or something like that. Like you could use any like provider. So once you've written a framework in like Light LLM, you can, it's very like framework agnostic, like provider agnostic. So let me just read what's here. The agent framework controls the flow of information. A part of that flow is the agent loop. The framework keeps looping till it has an answer. Not every prompt requires a function call. So if it can just reply, it'll just reply. Yeah, so next one. More on like the agent framework. What does the flow of information even mean, right? So what's actually the flow of information? An agent framework is a piece of software that facilitates the delegation and handles the words to action part, and provides necessary tools and components to create and manage and operate AI agents. So that's kind of like what a agent framework is. So we'll take a look at like what the responsibilities of an agent framework are also. So what it basically does, it coordinates like task management, and then tool integration, state management, and also another thing is like it also is responsible for like memory. So it like can either like make the agent forget things, or like add new memories and stuff. So that's also another thing that'll come in like later on. And like the decision making, and then communication between like APIs and stuff. Yeah, so that's the agent framework part. Then getting into like the agent loop, I think we saw that earlier a little bit, but the agent loop is basically like you see the prompt, and then you select the tool and the inputs, and then you send it off to like the agent framework, and then you get back the response from the tool. And then once you have a response, you kind of decide, like that's the loop part. You decide whether you want to loop back, do another tool call, or kind of respond to the user. So yeah, so let's actually take like a better look at an example of like this agent loop, and what it kind of looks like. Because me just saying it, I feel like doesn't get the idea across a lot. Let me, so I'm opening this little project here. So I'm going to go into this agents loop thing. So in this example, I kind of have like a coding agent, right? So let me just so what this coding agent is responsible for is like, can you write some code to find like the largest numeric palindrome? That is a multiple of n below n. So it's given a problem. And what I want to illustrate in this example is that like how it kind of makes decisions, and like what that loop is like. It's not always going to be talking to us, and just showing that basically. So we're creating a coding agent over here, and we give it GPT-4o. Memory, we're setting it to empty. So it's just empty memory. It's gonna just run like with the coding instructions. And then the working directory, I've set this as solutions code. So this is solutions code. So it's run once before. So let me just get rid of the solution. I got rid of the solution. Did I delete something? I think I deleted the solutions folder. Okay, just delete this. That's not current. Okay, it's that. So let me just run this, and you can kind of see like how it runs the agent loop. So it's trying to figure out like how to solve this problem. So right now you can see like it created a file, I think. It's doing its thing. It runs pretty fast. It's just doing its thing right now. Would you like to save this code to the file further? Yes. It sometimes asks for our feedback, and now, okay, so it's asking for permission. Yes. Okay. Would you like anything else? Okay, so it's asking if we need anything else. I'm just gonna kill the program at this point because we don't actually need anything else. Because I think it did. Did it answer our problem? No, actually, I don't think it did. But you can see like the agent loop, right? It's just writing code and like executing it and trying to figure out. Oh no, largest palindrome. Okay, 888.98. Okay, yeah, it solved it. So let me just go to start and kind of show how the agent is thinking and how this like information flow is happening and everything. So let me just go to the top here. So how it starts is like it manages its own memories and it adds this manage code. It's using this manage code tool to actually add this palindrome file. I don't think it actually sees the palindrome file, so it looks at the requirements.txt, and then it like views the project structure. I don't think it's supposed to do that, but it's doing it. And then here's a plan. So it creates a plan on how to actually do this entire thing. And then it like creates some code. The code successfully found. I actually don't know how it, okay, so it's actually running the code. Yeah, it uses the code execution tool over here and actually runs the code, I think, somewhere here. Actually, not sure where it runs the code. Okay, here we go. Execute code snippet tool. Okay, so it's using the code snippet tool to actually execute the code that it created, and then it found the answer. And continuing down, I think it saves it somewhere. Okay, so we tell it to save it, so it saves it there. And yeah, okay, so it finds the answer through the code execution tool. Okay, so that's kind of like the agent loop, right? It's thinking and then doing and then coming back and then like sometimes talking to us. And that's like the agent loop that I kind of wanted to highlight. So I say like, are there any questions like after that like example? Just go back here. How do I go back? Oh no, okay. Okay. Okay, we're back. Okay. Any questions like so far? Let me open the chat. You guys can like add any questions. So like raise your hand if you have like a question or anything. I'll just wait for a little bit. You guys can type. Oh, anything. I guess it's pretty clear so far. I feel like there hasn't been like too many new things. So I'll continue with this like next one. Either way, like if there's any questions, just like add them into the comments. Slideshow. Okay, so now like you guys understand like the agent loop, right? Now we're going to be looking at how like agents kind of work with like LLM streaming. Now that you guys have kind of like a basic idea of how it works and stuff like that. So how like function calls kind of work during streaming is you have like the normal like tokens, right? So you get like the normal token stream. And then like when you actually want to kind of break off and start an action, what you do is like you start with like the action token, and then the framework kind of knows you're doing like a function call, right? So on the framework side, it'll start listening for function calls and stuff and adding that into like a separate like array or something and collecting it differently because we want to actually process that differently. And like tool call stuff come in, stuff like this tool call stream comes in, and then once we're done with the tool call stream, we have like a end tag, which is like the end like action like token here. So you end that action token, and then once you end it, right, the framework kind of knows, okay, you're done with your stream for now. We'll just take that like action you want to do right now, and then the framework kind of processes that, gets the tool response, and then sends it back to the LLM, and then you start like a new stream, right? It might seem like one big stream from the example because like it's like just keeps going, right? But the stream actually ends here, and then we get the tool response, send it back to the LLM, and then you just continue the stream with that additional like information. And then you just have like the normal stream, and this continues like on and on and on till the task is completed or like whatever needs to be done. So like now I guess let's talk about like the like memory basically. So LLMs have always kind of had like memory issues. Like if you want to have like a PDF and feed it to like a LLM, it's quite difficult because you can't like fit the entire PDF into kind of like the agent, right? So you had things like rag loops. You still have rag loops, and rag loops are like really effective, and like you get that information that you're actually looking for, right? You just add like the information that you want, and you augment the generation, retrieval augmented generation. So like that was how we added information like before, right? But you technically don't need to do that anymore because agents kind of introduce the idea that LLMs can kind of think for themselves, right? So it's like with us, you forget something, you can quickly like look at the internet and just bring that in. So like agents kind of solve a bit of that memory issue that like LLMs have. So you can, if you forget something, you can double check on the internet and then tell that to the user. Or if you want to do like a search tool, right? So RAG becomes essentially just a search tool, right? So you have this PDF, and then the user asks, could you find like the Q1 financial reports or something like that? So if I was the agent, I would type Q1 financial report, and then just get whatever text is there, augment my generation, and continue. But like another interesting way that LLMs can actually kind of like update their own memory is like, let's say I say a really cool fact about me, right? Like my name is Hansa or something like that, or some kind of fact, right? It can choose to actually remember it. We can create a tool that can add that to the system prompt so it'll always remember it. So that's like another really cool way agents can actually solve this memory issue that agents like LLMs usually have, right? if we go into like the next slide, there's this really interesting paper called MemGPT. And MemGPT actually proposes like LLMs can actually do this, right? Agents can actually manage their own memory. We don't need to baby it around and tell it, we need to manage memory and stuff, right? They can manage their own memory. So the title of the paper is like MemGPT turns LLMs as operating systems. They're saying operating systems because operating systems kind of manage their own memory, and it's kind of like a similar concept to that. So yeah, so let me just go to the next slide. Here's like an example of like this memory management that actually happens. So let's say, so this is taken from like the MemGPT paper itself. So how is James doing? Any plans today? So that's the LLM asking the user, and then the user responds, James and I actually broke up. So like the agent can actually update that information like within itself, right? So now it knows like the relationship between the user and their like partner is like different now. So they can actually update it from like boyfriend to ex-boyfriend. And then like that information is kind of stored within like the system prompt, right? So next time the user like talks about them or anything like that, they'd have like context specific information that like you don't need to have that entire conversation fed to the LLM, right? You can end that conversation and save so many tokens actually. So like that's kind of like the idea that MemGPT kind of has. Yeah, so that's like another example. I think ChatGPT now does this really well, where you like say something like randomly, right? And then it'll be like memory updated and you'd be like, okay, so what's it saving? So that's technically what it's doing in the background. So that's something like in this example, I'm saying something like my favorite band is 21 Pilots. Could you recommend similar bands, right? And ChatGPT, you can see, is like updating its own memory and saying, favorite band is 21 Pilots. And then it starts, so this is a tool call, right? The memory updating part. So that's like another way like agents can actually solve a bunch of issues like with memory in like LLMs and stuff. So you can see like then makes like the recommendations like Panic at the Disco, Fall Out Boys, and like etc. Right? So I think like let's kind of take a look at like this memory management like example, right? Okay, so back to code. Let me just so I think instead of going through like the memory management example, I think because like the last part's gonna be a bit long. Like because this kind of shows the memory management thing over here. Because and then in the last one also we're gonna be implementing like memory management. So like I think we're gonna like just skip that part. Let me just go back here. Memory management, we can do the same thing. Let me just show that code though, like really quickly. We'll be revisiting the code at the end. Agent framework, this one. This is kind of the last example that we'll be looking at in the last section, which is like this like memory management thing. And you can see what actually happens is this memory management agent, it has like every like all the rest of the code like normal, right? And then you have this memory system prompt. If you go into this memory system prompt, you can kind of see like we're explaining how its memory works to itself, right? Your brain kind of runs in short bursts, allowing you to manage your memory between runs, right? We are making it aware of like its running circumstances and stuff. And then we tell it, right? You have something called persistent memory. And we tell it persistent memory is a key value type store thing. So you can add things and remove things and like do all of that stuff. And then once you go to like the memory tools, we show it like scenario, removing item, adding item, editing item. And we tell it that you can manage your memory like this. So if you hear something important, you know, don't hesitate. Just like add that into your memory, kind of how we remember like important things. Like if your friend says, you know, my birthday is this thing, you kind of write that into your head. It's like, okay, October 1st, October 1st, right? So similarly, agents also have that capability with like these memory management tools. So just wanted to like add that we'll be revisiting that part a little bit. So exploring, yeah.
Yeah, Hansa. So I think this is where we talk about the framework section. There's been
Oh,
a
yeah.
mishap. Yeah, it's kind of missing. We've been updating two different slide decks.
Hobby? Me
But that's
just
fine. I'll just go ahead and share my screen.
wait, give me 1 second. Did I think I didn't refresh the thing after.
Yeah. Oh, probably
Okay,
that's
I thought
it.
it just automatically synced. Okay.
Yeah,
Really sorry about it.
I was getting confused myself too.
Yeah, me too.
Okay, so I think this would be another good point to stop in and answer some questions.
Yeah. Yeah.
We couldn't mention earlier. So we remember that the organization committee told us that there's like a 30-minute session at the end of it to answer questions. So yeah, we'll have some time at the end of the whole session to answer questions in general. But we would like to use some of that time in between these sessions so you can ask questions, make it much more, you might not remember the beginning of the session at the end of. So you can go ahead and ask some questions now before we move on to the next section. And there's a question on Slido, is it? Yeah.
Slido.
I see.
Slido.
So there's a question, there's no name. It says that the question is, LLM agents only useful for vast amounts of text data. Well, that's pretty much not necessarily the case, because it's not really dependent on data or how much data you have, whether it's only a little amount of data that you have. I think LLM agents are useful um, uh, when you need to create agents that has the ability to understand context in natural language, right? And decide actions based on the context that it has, right? So it has the intelligence in itself. It's trained to understand context and respond to it. And we'll sort of, just like Hansa showed earlier, we'll be able to sort of give it like a prompt to say how how this particular LLM agent has to act, and what sort of tools that it has access to, what sort of things that it needs to do. We can give in that sort of data, that sort of information, and it will decide what to do and kind of create the workflow in itself. So to answer the question, well, it's not necessarily the case, right? It's not vast amount of text, because like Hansa mentioned earlier, even if you have a PDF, um, now if you think about models like Claude, you can just plug in your complete PDF or maybe a bunch of PDFs because the context is longer. But when we come into agent sort of problems, we usually don't do that, mainly because that's sort of expensive when it comes to token accounts. So what we usually do is augment the prompt with necessary information, and we'll be querying information that you need based on the prompt or the task. So that's sort of a way to go. I hope that answers the question. And if you want, I'm not sure, so there's no name. So if there's any follow-up for that, you can go ahead and post it there itself, and we can respond to it, or any other questions that you have in general. So I guess there's no questions. Or is there? So what is the best and easy way to develop AI chat assistant? Do you want to answer that, Hansa? I think you're on mute.
Now I seem a little silly. So I think the easiest way right now would be kind of LangChain, right? Such a,
Yeah,
because
I
there's,
agree.
yeah, there's a lot of like documentation around it and stuff, and especially for chatbots, it's probably LangChain. If you want to do something more complicated though, you probably want to go with something like AutoGen or Crew AI or something like that. But if you want to go really complicated, write it yourself, I'd say.
And that's what Hansa will be doing at the end of the session. How you're going to
Yeah.
write it yourself. And so yeah, we'll talk about it. But once again, there's no such thing as best way. But I think the second part is correct. There's like the easy way. So the easy way is using LangChain, because like Hansa mentioned, there's like there's a bunch of different already made ready-made tools that you can use out of the box from LangChain, and there's other frameworks that you can use. Obviously, LangChain is just a little bit too common and vastly supported by the community. There's like a lot of other libraries that's built around it, so it's quite easy to build. So I'll just do a demo on LangChain and AutoGen. And so we didn't want to stick to frameworks in this particular session. We wanted to kind of show you that you can, like anybody can use the framework, read the documentation and implement it on your own, right? So we're not going to stick to frameworks, but I'll be showing you some examples on how you can build something with LangChain and AutoGen, just a very teensy bit of an example right next. And then we can go to the next part, but what's the next question? Okay, so like I think we mentioned a little bit about RAG, right, Hansa? So the question is, can we explain a little bit about RAG? So well, just like what RAG means is it's like retrieval augmented generation. So in like, so I don't want to speak to RAG here because it's quite specific, but if you talk about it, now, I mentioned this earlier when I was talking about LLM-based agents. That's where you can just give it a prompt, your LLM. You can just give it a prompt and then expect a response. And then the model would just use its pre-trained information and its fine-tuned data to sort of generate a response, right? And it's not current. It's not specific to your private data, because let's say a model is not fine-tuned on private data. It's not fine-tuned on that, right? It's just giving you excuse me, it's just giving you a response based on the prompt and the fine-tuned data. So if you want to sort of like make it specific to maybe your company data, your university data, what you can do is you can use a retrieve, like a RAG approach, where based on the prompt, let's say you have a set of information about the students in the university, right? And sort of a history, like a profile on them, and you're asking the LLM, or maybe you're asking the agent to sort of give you some information about the students who have high scores in this particular subject, right? And then what it can do is it can now, when we talk about high schools, it can now, your agent can retrieve information. So there's different retrieval methods. I don't want to stick to specific to that, but there's like different retrieval methods that will match your prompt with the information database and then bring the most relevant information from that particular database. It can be PDFs, anything, right? Bring that information and then it will augment your prompt. And that's why we call retrieval augmented, right? You sort of attach that additional context into your prompt and then you feed it to the LLM. So we know that if you are given a context and a particular instruction, LLMs are really good at sort of identifying the information that's and organizing it into a nice response, right? So that's basically what RAG does. I hope that answers your question, because here we didn't want to stick to RAG specifically. That's why we are going towards agent frameworks. But that's like a high-level overview of RAG. So those are the questions on the meeting chat. I think there's a few questions on Slido. So what would be the best LLM for agents? So once again, I don't want to be too biased, but OpenAI sounds like a good choice. But then again, it's up to you, because nowadays there's a lot of models that's coming out. That's just as good as OpenAI models like GPT-4 and so on. So it's pretty much there's some models that are good at different tasks than others. So you just can't say that it's best. Just that mostly OpenAI models are used in projects out there, right, Hansa?
Yeah, and also I'd say like it needs to be fine-tuned for function calling, because if you take something like Mistral's a good LLM, but it's not a good agent because it might not be like properly fine-tuned for function calling, because it needs to be able to do like those action tags and stuff, because if you keep explaining it in like the system prompt, it's just a waste of tokens. Just fine-tune it into the like LLM so it knows what it's doing. When you tell it to do a function call, it just does the function call. So yeah, it needs to be fine-tuned.
As long as it's fine-tuned for your use case, any model is good. And if it's shown to be good at the task that you're working at. So any thoughts on RAG on images, mostly multimodal? Well, say if your question is whether you can use images in a RAG-based approach, so most of this information, this is too specific that I think Hansa has a little bit experience on this area.
Yeah, so if you want to do multimodal RAG, it's pretty, I'd say simple, right? Because you just have to put them in the same embedding space. I think Clip kind of puts everything in the same embedding space. So like text and like images, as long as you have like images and text in the same embedding space and you do run like a vector query, right? So you say something like dogs or like Dalmatians or something like that. You can get images of Dalmatians, you can get text of Dalmatians, and kind of give the most essential like text and images of like the Dalmatians or something like that. It would be able to answer it, but I'm not sure like why you'd want to do multimodal RAG. Probably a diagram or something, right? You'd have like a scientific diagram list or something like that, or like yeah, I feel like something with diagrams, right? You can definitely do multimodal RAG.
Yeah, that's the thing, right? But like what sort of use case can be beneficial? But yeah, like Hansa said, most of this information you kind of use a vector store and then have it in an embedding space. So as long as it's in that particular space, you can use the sort of retrieval approach that you're using and then bring relevant information. It can be text, images, documents, whatever. So
on adding agents in production. Okay, so I think there's a bunch of like agents in production, like at Search, if you really think about it. I'm just thinking like the actual agents that are currently actually being used by users. Actually not a lot of them. I'm just gonna say it. The thing is, like agents right now, they're quite expensive, right? So if there's gonna be a huge user base, then you know, it's gonna be quite expensive. And yeah. So I'm just thinking, okay, so let's just talk about the deployment part, right? So deployment's pretty easy because LLM is going to be on OpenAI, Anthropic, or some other place, right? So we don't have to deal with anything related to like the LLMs. And the deployment is the agent framework that's just going to run on like a fast API server or like literally just any server. You just, so everything is stateless, right? So if you're talking about deployments, because you're going to be storing the messages on a database, agent framework over here, like on the server, and you just get the user's queries with like the conversation ID and the user ID, right? And you can just get that conversation from the database, continue it from wherever the conversation just ends, right? And yeah, so it's just, you can run it on Lambda, you could run it on anything. It's just a normal server.
Yeah,
Like,
as long as it can run Python, and if your thing is implemented with Python, you can implement it with other languages. Just that Python is quite easy, and then you can just run it.
LLMs, you can definitely like use the agents in production. I'm just saying, but right now I haven't really seen too many LLMs agents in
So-
production. Yeah.
Oh, I was just wondering if the question was aligned with, where do you host? If you're working, I'm not sure whether the question specifies that, but if you're thinking about the models, right? You wouldn't worry about it, at least in a production use case, you wouldn't worry about the language model itself of hosting it. Usually you'd use a like provider, like Hansa mentioned, like OpenAI, Anthropic, anything. And if you're thinking about hosting a model on your own, you would probably need like a GPU server, and then for that you would have to have VMs. You can set that up on different instances. Like there's easy use cases like model.com. They provide like a bunch of GPUs where you can host your own models. If that's what you were asking, yeah, we could do that.
Sachit, there's a lot of questions.
Yeah.
And we don't have like a lot more time. I think we have about like 45 more
I
minutes.
think
Yeah.
10, 12. I think we have until 1, right?
We have till 1. Okay. In that case,
Shall we continue with the session and answer these questions in like the next break?
yeah. I think that makes sense.
Yeah. Okay, we'll get to these questions later on. I mean, at the end of the session, we can obviously answer all of your questions. Okay, so right, so Hans, so that's now. So like now we've discussed about what AI agents are, how LLM agents are, I mean, what components that they have, and what the architecture of these AI agents are. Hans explained a few different things, right? So to implement these AI agents, like there's a bunch of different frameworks that are out there. And we mentioned a few like LangChain, AutoGen, Crew AI, and Llama. And these are frameworks built to create AI agents. And we didn't want to stick to specific frameworks in this session and then focus on how to build a chatbot using LangChain, how to build like a multi-agent setting using AutoGen. But we thought of introducing you to some of the concepts, some of the basic concepts around LangChain and AutoGen, and then just move ahead with the session. So at the end of this session, so Hansa will be going through like an in detail implementation of AI agents. So you'll be doing it from scratch. So you'll get a basic understanding of how these frameworks really work. But to go through a few frameworks that are out there, one of the most common frameworks that are used in production use cases is LangChain, right? So LangChain is like a framework where you can develop apps that are powered by LLMs, and it kind of has all the basic toolkits, and it has a sort of community support, community libraries that you can use to build applications pretty easily. And I will show a small demo of how we can implement like a small like a web search application using LangChain, and it's pretty easy. And so, like I said, it contains all the necessary building blocks, right, to build complex applications. And there's LangChain is made up of a bunch of different libraries, and LangChain Core is like the library that contains all the base abstractions and sort of the LangChain expression language, which I'll get to during the demo. And it has all the necessary components that other community libraries can build upon. And that's where the LangChain community comes in, and it has third-party integrations like Google search integrations, and let's say different providers like OpenAI, Anthropic. They can have their own implementations from LangChain and have them all in the LangChain community library. So there's so many integrations in the LangChain community which we'll see some of them in the demo. And most of the partner, like OpenAI and Anthropic, are like two powerful in the world of LLMs and agent frameworks. So like these two libraries are like partner frameworks with LangChain, and they're sort of supported out of the box. And then we have LangChain, right? And that's where you have sort of the chains and the agents and the way that you can retrieve information from vector stores and so on. That's where all of these stuff are built around. So now I'll share this slide. We'll be sharing this slide deck with you as well, so you can go through this link to understand the concepts in detail, because we won't be able to explain everything about LangChain in one session. So the only way that we can do is like give you a small demo on how LangChain works, right? Like what sort of basic concepts are out there. You can go ahead and go through that demo, understand the different concepts that there are. It's pretty much just like a read and understand situation. So to show you a little bit about the LangChain in implementation or LangChain in action. Right, so there's like a question that say, can you show demo in create chatbot system with custom instructions with LangChain? Okay, we'll see if we do have the time. I mean, we had this session pretty much pretty organized, and some predetermined examples that we wanted to share. And what's this about the PDF? Is it the slide deck you guys are talking about? There's like a mention of a PDF. Sasanka, is this, if Sasanka is here?
Yeah, sorry, Mr. Sachith, I missed your question.
All right, okay, so there's a mention of a PDF in the chat. So I think it's the slide deck, right? This slide that we are showing here.
Yeah.
Yes. Okay, got it. Sure. We'll be sharing everything that you see during this presentation. We'll be sharing it over to you, including all the notebooks, any code implementations, all of it. We'll be sharing it with you. Okay, so now moving towards the demo of LangChain. Now, I really don't want you to stick to like a particular framework, because you can obviously go through the documentations that there are, and then you can get used to it, right? So I'm just going to open up these two. So here we go. Right now, so let's go ahead and run this. So now here, basically, we are installing LangChain and LangChain. Now this is one of those community libraries that I mentioned. So like I said, there's a LangChain community, right? There's third-party integrations and other tools that are integrated into LangChain. So they come in different libraries. So this is one of those libraries where NVIDIA has built a library to communicate with their models, right? So it'll be easy for us to approach them. So I shared a PDF through Sasanka to you guys on how to create an NVIDIA account. So I'll just go through it here. Right? Can I just hide this? Right. So where's that PDF? Here we go. Right, so I share this over where you can create a NVIDIA developer account. The reason that I share this over is because maybe not all of you have access to OpenAI and OpenAI API keys. So with this, we can create a developer account, and they give each of those developer account with free credits that we can use, and we can use that for experimentation, right? So it's it's very self-explanatory. You just need to go to this link. I'll just put this in the chat. Sasanka, can you please put this PDF in the chat for me so that they can follow it along? You just need to go to this link, which is the NVIDIA developer workplace where you can create an account easily, right? So you just need to, I'll just open this up in an incognito because I've already created an account there. Very easy. Just go ahead and then you can go ahead and click login, right? And then I highly recommend that you use your university email here because that would give you like 5,000 credits. So go ahead and use your university email, whatever you have. So if you don't have, just use your private email, whatever. For that, you'll only get like 1,000 credits, but you can still use it. So you can go ahead and type your email and then hit next. Right, so you can go ahead and since I've already created an account, they're asking me for the password. But you can also go ahead to the more login options, and they have a bunch of SSOs. You can use Google or any of these options. Or if you're using your university email, they will probably ask you to type in your password and confirm the password. So go ahead and create that account, right? So I mean, it's pretty easy. You can just go ahead and create the account. And once you've created the account, right? And once you create the account and you've logged in, you'll be able to see that you've received 1,000 credits, right? So if you used your university email to log into this, you can go ahead and request more. And then there's like a bunch of details that you need to fill in about you, and they'll give you the extra 4,000 credits. So I've already created an account, and if you want to follow along with me, I'll also share. How do I get the meeting controls back? Okay, I'll share this here, right? So here's the collab. And once you've created an NVIDIA account, so I have it here. So once you can use any model that you are comfortable with, but I mean, so Llama 3.1 for 405 billion model is quite powerful these days in the open source community, and it's also fine-tuned to use different tools, right? You can use different tools, not limited to these, but you can since it's fine-tuned on tools, you can sort of use it as an AI agent. You can use it in an AI agent setting. So this is the model that I'll be using. So something interesting about NVIDIA is that they don't really charge you based on what model you're using or whatever. So any model, you can use it, and they will only charge you for a single call, and it's not token based as well. I'm not going to get into the details. If you're familiar, you might know with OpenAI, they will charge you based on the number of tokens that you input and the number of tokens that you generate. Here with NVIDIA, it's just if you send in one single call, you'll only be charged one credit, right? So it's that simple. So once you have your account ready and then you selected your model, and in this case, we've selected this model, you can go ahead and click build with this name. And there's like an API key that is given to you for this particular model. You can copy it up. And then now in our notebooks, right? So since you don't want your API keys exposed, it's better to put it into like a notebook secret. So you can go ahead and add a new secret, and you can type whatever you want, right? So usually you can name it as NVIDIA API key, and then you can paste your key here, right? And then I'm going to delete this because I already have an NVIDIA API key. And once that's set up in your notebook, you can use the Google Colab library to access that particular API key, right? And then you can set it into your environment variable. So I'm not going to get into this, but here what we're doing is we are setting the environment NVIDIA API key variable with the API key that's here. So when we run that, it could the environment variable will be set up. And then since we installed LangChain NVIDIA AI endpoints, we can go ahead and import the chat NVIDIA class and then instantiate our model, right? And the model that we're going to be working with here is Llama 3.145 billion. So we go ahead and run that, and we'll have a model instantiated. And from LangChain, now you might be familiar with system messages and human messages. So from LangChain core, you can LangChain core.messages, you can import the human message, which is the user message particularly, and you can import system message. So these are sort of, like I said, LangChain core has the abstractions. So they've sort of abstracted away all of it, and then we can build upon these abstractions. So we can create a system message, and we have said that translate the following English into Italian. So this is the system message, and the human message is a simple hi. So we can type whatever we want. We'll say hi, how are you, right? And that's like the content that we have in the human message. So the system message is to translate this from English to Italian. And since we've already initiated the model or instantiate the model, we can go ahead and invoke this with this list of messages. And when we do that, we would, oh, I think there's a problem with the API key. Let's go ahead and update this. Let's delete this. I probably generated a new NVIDIA. Right. Let's run this again. Grant access. Let's try it again. Oh. Yet. Right, so there we go. Just a bunch of authorization issues that we ran into. So with this system message and human message, we have a list of those messages. And when we invoke the model with these messages, so it's actually translating it. I mean, you give, the model is doing what we just asked it to do. It translated from English to Italian. So it says, ciao, come stai? I hope that's the way to pronounce it. So once again, you return an AI message. That's once again an abstraction with the content. And then you have a bunch of different other information that you get, like how many tokens were there in the prompt, what's the total tokens, and how many tokens were there in the completion. All of that is sent along as well. So that's a pretty much easy abstraction. Now you could go ahead now with this information. You really did the rest of the information is not pretty much necessary for us to do our problems. So you can go, if you want to access this particular message only, what you can do is you can get this into like a response variable. So let me do that again. You can have that in a response variable. And then you can go ahead and type response dot. We know that there's like an attribute called content. So if we type response dot content, we should get the actual content that was within it. So even for this, there's like an abstraction that's created from LangChain itself. So there's something called output parsers. So you can check this out in the documentation. There's so many output parsers that are there, like XML output parsers, CSV output parsers, so many. And one important one is the string output parser. And with this, what you can do is, now we know that response itself is just an AI message, right? It's an instance of AI message. So if we pass this response through the string output parser, we can simply get this message. Like, it's just abstractions that LangChain have created to make it easy for us. So, so we are importing it and we are instantiating it. And when we invoke, now this is once again, we are running it again. So this is not necessary because we already have it. So we already have it in response. So if we invoke this parser with response, then what would happen is you would see that it would extract that message, the content from the AI message that was returned. Now that's pretty neat. You have like some pre-built things within LangChain to do simple things like calling the model and extracting the content in itself. Now, the power of LangChain actually comes by chaining all of these things together, right? And that's why it's called LangChain, right? So what you can do is there's something called LangChain expression language that comes with LangChain. So I'm not going to go deeply into what this is, but they have built sort of a chaining language that that you can use to build different components and then join them together, right? So we can create this chain using this language, this LCell. So one important operator that it has is this pipe operator, right? So this pipe operator, which is just above your enter, and you might notice this, it's just above your enter key if it's new to you. So what the pipe operator does is it chains these things together, right? So we have our model, which is just a chat NVIDIA model, right? We've instantiated it. So we chain that with the parser, right? So the parser is actually the string output parser. And what it does is when you invoke the parser, it just extracts whatever message that you have here. So when we chain all of it together, you can simply invoke this chain with the list of messages that we created here, right? So we have a system message and a human message. And you can go ahead and simply invoke it, right? Now, when you invoke this chain, what would happen is it would first go to the model, invoke the model, and whatever response that you get, you would then invoke the parser with that particular response, right? So it's like chaining all of those things together. So you'll see that at the end, you'll just get the response. So now this is something that LangChain has abstracted completely away for you to get the response itself. Another thing that comes with LangChain is this chat prompt templates, right? So prompt templates are something that comes along with it. You can create your own prompt templates and then you can edit them. So one example that I created here is that once again from the LangChain core, this is where you have all the abstractions. You bring the chat prompt template, and then we have this system message, right? And in this system message, now earlier we just said translate the following from English to Italian. Here we just have translate the following into language, and language is like a variable, right? You can set it up during you can instantiate it dynamically. So we'll see how we can do that. So with this system template, we are setting our prompt template, and that's from the chat prompt template. We are just saying, here's the list of messages, create a chat prompt template, right? So chat prompt template from messages, we are passing in a list of messages, and we have a system message, and you can obviously just have it here, right? I just extracted the way. So you can have this here. That's the same thing. Okay, so you have the system message, and then you have a user message, and then you have that this prompt template is created for you. And then what you can do is, now these are variables. Language is like a variable, text is a variable. So this prompt template, when you invoke it, you'll obviously have to pass in this language and text as like a dictionary, right? You have to pass in values to these variables. So to the language variable, you'll be passing in Italian. You can pass in anything for text. And for the text, you're just passing in hi. Let's say, how are you? Okay. I am doing a presentation at IIT. Okay. And then when you just invoke it, I'll just show it to you. So what you would have is like a chat prompt value with the list of messages. So you have the system messages and you have the human message, right? So what this chat prompt template did for us was it took our list of messages and it created our message list like we did manually here, right? So it's sort of abstractions little by little to the top. So with that, right? Now, once again, I told you that chaining is the power of LangChain. So what you can do is you can go ahead and then you can go ahead and chain it all together, the prompt template, the model, and the parser, and then you can invoke it. But remember that the prompt template requires to give you these two variables, values to these variables, and then you can, let's say, I'll just say Spanish here. And then it would say hola. So the text is hi here. So let's just get this text here. Right, so here you go. There's a translation. So hola, ¿cómo estás? Estoy haciendo, so on and so on. Right? Okay. So that's basically like a few different components that I've joined together. And using these, right now with these concepts, there's different concepts with LangChain. I've listed a link. You can go and read those documentation to understand more about it. And so I created a small LangChain agent as well. So I think we're running up on time as well. So for the autogen part, I'll be quickly going through it. I won't be going in detail for the autogen section. So for to build a simple LangChain agent, so I'm going to create an agent where we do a quick query. Whenever a user passes in a query, if the agent realizes that it does not have enough information to answer this, it would do a quick search and then retrieve information and answer based on that, right? So for that, we need this LangChain community and then LangGraph, and then the NVIDIA AI, this AI endpoints I installed earlier. And then there's something called Tavily. I'll get to it. And then all of this information, I'm not going to go through all of them. Let's get to them as we come. So Tavily is like a search engine that's optimized towards AI agents, right? So you can you can go ahead and search for Tavily. And then you need an API key from Tavily as well, right? So you can go, you can create an account easily. And then once you go to your dashboard, you can get an API key. You can generate an API key from here, right? And then you get 1,000 credits per month from Tavily as well. So that API key, once again, I have it in my list of keys here, Tavily API key, and then I pasted it here, right? So this part is once again from new. We are setting up the environment variables with those two keys and run that. And then, so LangChain, from the LangChain community, right? So they have the tools. Now, searching now, we'll be talking about a bunch of different tools in the next section. So searching is like a tool that you can augment AI agents with, right? Just like memory and then calling functionalities. Searching is also another tool, like Hansa mentioned. If you can, I mean, if you can implement anything in Python, that can be a tool. So in the LangChain community, there's like so many tools that you can use. So I'll share a bunch of links where you can look at the different tools that LangChain has out of the box that's already built into LangChain community. There's Tavily search already built, and so we are going to import this Tavily search results. And then so just to make it easier, we are going to limit the maximum results that we get from the search engine to be 2. So because otherwise you would get like more than that. So I think the default is about 10 or 15, I'm not sure. And then you can, the way that you talk with the Tavily search results is once again similarly, you would just have the search and then you invoke it with the query that you have, right? And then you print the search results. So if you print it, so I'll just run this. Right, so then you have this set of, so I'm just going so here it returns the URL that it took the information, the content that it has. All of those information is brought to you in a list, and that information is there when you use the Tavily search, right? So what you can do is you can now you can create your list of tools by now search is a tool, right? So you can have a list of tools. You can have a bunch of different other tools. If you're using other like polling functionalities, you can import them, configure them, and you can have those different tools here. So for now, we are just having the search tool only in our list of tools, right? And this is something optional. We are just looking we are looking what models support using tools in the NVIDIA library, right? So I mean, in the NVIDIA NIMs. There's like so many models that are there in the NVIDIA NIMs library. So we can check using this command. I'm not going to keep explaining. You can look at it later. With this command, you can look what models support using different tools. Like we mentioned earlier, it needs to be fine-tuned to use tools, right? So here, luckily, Llama 3.1 4 or 5 billion supports tools. So we are going to use it in this use case as well. So we are instantiating our model, and then we defined a bunch of tools, right? Now it's very simple. We defined a bunch of tools as a list, but all you have to do with LangChain is you can go ahead with, you can use the bind tools function to sort of connect these tools into the model. So what happens underneath is that this Hansa showed you how these words to actions are converted, right? So in LangChain, these tools, they have different descriptions on what these functions do and what each of the arguments that are in there. It has a description, and those descriptions are attached to the model, right, into the system prompt. That is what happens underneath. But with LangChain, it's abstracted completely. So all you have to do is use the bind tools and attach and then pass in your list of tools. And then we are importing human message, and we're just saying hi. Now you can see that Hansa earlier mentioned that if the model realizes that you don't need to use any tools, then it's not going to be calling any tools. It's just going to be responding to you, right? So if you just pass in hi, now you have a model with two. Now this is a completely different model from the earlier one. Okay, now in LangChain agent, we are starting from new, so it's completely different from the translation example I did earlier. So you pass in a human message. So there's no system message. You just say hi. And when you run it, so you can look at the content and you can look at the tool points, right? I will show you. So when you just pass in hi, so the model knows that it doesn't need any tools for the moment. It's just going to say, hello, how can I assist you with today, right? And you can see that in the tool calls, there's no tool calls at all. So if I show you the response now the response is what we are invoking the model that has the tools combined with it. So let's go ahead and look at response. So you can see that the content, it's once again an AI message with the contents, and then it has the content, and there should be a tool for. Am I missing something? Okay, I think I'm missing something. Okay, so I think it's because there's no tool calls at the moment. All right, let's just go ahead and run the next and see what happens. There should be something called tool calls. Let me run this again. Probably because there's no tool calls at the moment. Okay, so let me run this next part where we are going to ask our model, like, what's the weather in SF? So SF stands for San Francisco, and when you run this now, so now when we are asking what the weather is in San Francisco, now the model does not have, it cannot answer this question on its own, right? So what it's doing now is it identifies, now you don't see anything what's happening underneath because all of it is completely handled to you by LangChain. So it decides that it needs to call the function. Let me just see. So when you ask what's the weather in San Francisco, it knows that it has a like a terminal search function that it's binded with, and then it will it will bring the relevant information to call that function. So let me show it to you. Let's take a little bit of time. Right, here we go. So when you say, when you ask what's the weather in San Francisco, now it knows that it needs to bring information from the tool calls, right? So, I mean, it does not respond to you by saying, like it doesn't, earlier when we just said hi, it responded to you with a content, right? Saying, how are you today? Is there something that I can help you with? But here, when you ask what's the weather in San Francisco, there's no content, but it gives you like, like a bunch of tool calls that needs to happen in order to bring this information. Now, this is translating this, now, like we mentioned earlier, translating this query into an action. It's translating these words into actions. So the name of this action is Tavili search results, and the arguments that you need to pass in is San Francisco weather to the query parameter, right? So the Tavili search has a parameter called query, and then you just need to pass in this parameter, right? So that does not happen underneath, right? So just because the model tells you, okay, this is what you need to do, it does not do it for you. And that's where we come into the actual agent part of it, right? So now the model has told you what you need to do in order to bring this information from Tavili search, because Tavili search is the only tool that it had access to. So then here, from LangGraph. Now, I'm not going to go into the in detail stuff of this, but with LangGraph, what you can do is you can bring this create React agent. So a React agent is a type of agent that you can build to like based on the reasoning that happens. Like for example, here it decided that it needs to do a quick search with these arguments with Tavili. It will also act on that, right? That's what a React agent is. So React comes from react, right? So this is where React comes from, reason and act. So it will reason, and then it will identify what it needs to do, and it will act on it. So LangGraph is something again from LangChain. So you can, from the pre-built set of functions, you can bring this create React agent, and then you can pass in your model and tools, right? So this is different from where we binded the model, right? So from the React agent, once it has the model and the set of tools, let's go ahead and run this. You can go ahead and invoke this agent executor, this React agent with the message that you want, right? So once again, if you just go ahead and just run this with a simple message like hi. So when you run just something like hi, it knows that it doesn't need to use any tool calls. Now this is a React agent. It would just respond to your hi message. It's taking a little bit longer than usual, probably because it's something on NVIDIA's end. And then you get a message saying hi, and then so on and so on. And then but if you ask like, what's the weather in San Francisco? Now you can see that here, the human message. Now we are printing the list of messages from the response, and we have the human message hi. And so the AI message is, hello, how can I assist you today? And when we ask like, what's the weather in San Francisco, from the React agent, so what it would do is, now there's like a bunch of different things that happen, right? Now this is not pretty clear to you, but what happens is you can see that there's the human message initially, and then you have the AI message, and the AI message has, it does not have a content, but it has, here's the tool calls thing that I told earlier. So here's the tool calls, and here it's like, it has the configuration, like it's the Tavili search, and the arguments are San Francisco weather into the query, right? And then, so here's a tool message, that's where it can, and then it would go ahead and invoke that Tavili search on its own. The React agent will do that for you. It will invoke the tool, and then it will return the results, right? Just like we did manually. Here we did it manually somewhere around here, where we invoked the search, and then it brought the results. So you can see that the list of results from the tool is listed down here. And then after that, at the end, you have the final AI message, where it says the current weather in San Francisco is partly cloudy with a temperature of 63 Fahrenheit. So this is like, now this is sort of like a retrieval augmented generation, but it used a web search, right? So it brought the information, it's not tracked specifically, but it brought information from the web from the internet, and it augmented the final message, and it brought like a complete like a final answer, right? So if you print out final message, so you can go ahead and print it out. So the last message. So dot. So the current weather in San Francisco and so on and so, right? So you can go ahead and also do something like this where you print the message one by one, so you can see what happens in order, right? So here, what I did was just let the executor do the whole process on its own, and then just print it at the end. But here, what you can do is you can do something like a stream where each message is printed one by one. So here you have the first AI message. So the AI message is has planned to do a tool call, and then there's the tabuli search and so on, because that's the only tool that it has. And then so this is an agent, and then the tools, the tool will be invoked, and the result will be here, which is the list of results from tabuli search, and then you would have an AI message at the end. Right, so I'll let it run, and I'll introduce this part as well. Here, where you can add memory into your agent, that's once again from LangGraph. You have all of this built with LangChain from LangGraph. It comes on a checkpoint memory. You can bring this memory saver class, and then you create this. You instantiate a memory saver, and then what you do is, now when you're creating your React agent, you pass in your model the list of tools that the model has access to, and you set the checkpointer to this memory object, and then whatever conversation that you have will be saved. So, but when you are doing this, right? So I'm just going to go ahead and stop this because it's taking too long. But you get the idea where it does one after the other. First it gets the AI message, and the AI message is instructing that it needs to do a tool call, and then the tool call is actually called by the React agent. And with that response from the tool call, the final response is given from the AI, right? So let me just. So here we instantiate the memory saver, and then when we are doing like a memory saving agent type of thing, you would also need to set this configuration where you give it a thread ID, so that if you have multiple different conversation, the agent will know that it needs to resume this conversation and not the conversation that it had at this ID, right? So we are setting up a configurable ID here, and the thread ID is just ABC123. It can be anything. And then so I'm not going to show you the tool call part of it. I'm just showing you where the memory saving is happening. So you can say, hi, I'm Sachith. And when you go ahead and run that, it will say, so it says, hello, Sachith, it's nice to meet you. Yeah, is a blah, blah, blah. And then once again, when you run this agent, when you run this again, and remember we are passing in the config, which is this configuration. When you pass it in and then say, what's my name, it will have access to that previous memory, right? So this checkpointer, the memory saver, has the predetermined ways of how to save memory, and it does all of it for you, right? So I'm not going to get into how it happens underneath. So that part will be introduced to you by Hansa when we'll be implementing it from scratch. Right. So that gives you an idea. So we just built a simple web search agent where it does the search. It uses tabuli search engine to retrieve information, and then it augments it. And then we also looked at how we can save memory, right? So I'm also not going to stop at this point. I'm going to finish the next part as well. And then before we move on to the final part of this session, we'll answer a bunch of questions that you might have regarding the frameworks, right? So like I said, I'm not going to take a lot of time showing you the implementation parts. I'll just quickly go through them. I'll show you the implementation, just stick to a minimum explanations. But when it comes to Autogen, Autogen is also another framework. Now, like I said, you can go ahead for LangChain. You can go ahead and look at the bunch of different concepts that are there and the different tools that are there that are already built, and how you can build your own tools that you can integrate with LangChain. You can do that. It's pretty customizable, and you probably wouldn't have to build your own tools because there's so many tools in the LangChain community, LangChain community library. You can do a quick search LangChain community, and then you can see what type of tools are out there. So Tabily Search was one of them. So there's Google Search, Bing Search, and then you have other different type of other tools that you can use. So once again, with Autogen, Autogen is also another framework, and you can use that to build AI agents just like what we did earlier. And something interesting about Autogen is you can have different agents in your task. You can do that with LangChain as well. But with Autogen, that process is quite easier, right? So you would have you would define what each of these agents are and how those agents should behave. You define those agents, and then you can put them into one whole conversation and let them solve the task for you, right? So one example that we had during our session, during this same session was, I think someone of you asked where we can have like an email thread, and then Hansa mentioned you can have different agents, right? So that you can do that with Autogen, where you have an expert that is good at writing emails, and you define like what sort of information and how to write emails, what sort of format that it should use. You can define that in the email writing agent, and you can have a different critique agent that sort of critiques and tells how this email can be improved, right? And that's sort of a setting that you can do with Autogen, right? So you can so these are what we call is conversible agents, so where agents can communicate with each other and go towards solving a particular task, right? So for that you have and you also have tool support for this, and then you can have the human in the loop, where Hansa showed an example where sometimes the coding agent is asking Hansa's input. So with Autogen, you can do the same thing as well, right? So let me just show you some implementation that I have for Autogen. Right. So before moving further, let me just tell you here that in Autogen, you can define different agents, and then to represent the user in the conversation, like having now this will be like a conversation, right? So to represent, just give me a minute. It started raining and you might not hear me with all the noise. Okay, so you have different agents that you define in your Autogen sort of in your code, and then you have this user proxy that acts on behalf of you, right? So you can have this user proxy. I'll show it to you. You can have this user proxy behave in different ways. You can have the user proxy automated in itself, or you can always have the user proxy asking your input, right? So it will always, if you say the user proxy, if you configure the user proxy to always communicate with the real user, then it will stop when the user proxy is invoked, and then it will wait for your response. I think it's better that we see this in action, right? So let's go ahead and look at the Autogen parts of it. So once again, so I have this Tavily Python thing. So I'm not going to implement the Tavily agent thing. I'll just show you the code because it's taking a lot of time. But so you install PyAutogen, right? And then we set up the configuration. So I'm using, since we need the API keys for this as well, so we're importing the user data. And then we have the Tavily client here. And then we have from Autogen, we have the assistant agent. That's where you define your assistants. And here's the user proxy agent where you implement a user proxy that acts on behalf of you, right? And then what we first need to do is we need to first define a config list where you set up all the models that you have access to, right? So here you can define different models from OpenAI, from Anthropic, as long as, so Autogen supports OpenAI compatible models, right? So we have OpenAI Python package so Autogen only supports models that can be called with the OpenAI package. So with NVIDIA, it's the same thing, or NVIDIA NIMs can be called with the OpenAI package. So we can configure those models here. So the model is Meta Llama 3.145 billion instruct, and the API key is the one that we have in our secrets, and the base URL is here, so which you can actually access, where you can see the code part of it. So you can see that the base URL is this, right? So you can go ahead and copy that and paste it here. So this configuration, you can have other models as well, right? So you can go ahead and different other models. You can have as many models from different providers, right? You can have an OpenAI model here, Anthropic model, as long as it supports the OpenAI calling mechanism. And then you can have, even from NVIDIA, you can have a bunch of different other models. And then you can filter out which model you need for each agent, right? So that's one of the advantages that you get with AutoGen. So now we are going to we're going to instantiate the config list. And then we have the Tavily client here initiated as well. So, so in AutoGen, you need to define your tools, right? You need to define your tools using Python functions, and it's not that easy as LangChain. So I'm not really sure whether AutoGen now supports. I haven't used AutoGen recently, but with AutoGen, I'm not sure whether they have this community set of libraries like LangChain. But what you need to do is you need to define your function. So anything that, like you mentioned earlier, if you can define your function, that can be a tool, right? So the search tool, you are defining it here. You need the query for that function, and we are annotating it so that when we attach this to our model, it has sort of a definition of what the model needs, right? So that's why we have these annotations going on here. So the query is query has been annotated with the search query. So then the model will know that, okay, this query variable denotes the search query for the Tavily search client. And then what this function returns is the once again we have an annotated typing here, which says it needs to return the a string, and the description is the search results, right? So what this function does is it takes the query, and then it uses the Tavily client to get the search context. So this is something from Tavily. You can look at how to build a search client on your own. Maybe for Google search, you might have to do a different one. So this is for Tavily. We go ahead and run this. And here we've defined the React prompt on. So once again, we are building a React agent. And so we have defined the prompt and on how the agent needs to work, right? So we are saying, answer the following questions as best as you can, and you have access to the tools provided, and the tools will be attached later on, right? So here we'll be saying that you'll be given a question. So we have given the format that it needs to respond in. So the question the question will be given to you, and then it needs to first have a thought. You should think about what you need to do and what action it needs to take and the action input. And then we will also say that this process can repeat multiple times. And then at the end, we need a final answer, right? So now this prompt is actually defined in the React paper itself. So you can go ahead and read that paper. And this is the same thing that is used by the LangChain React agent as well. So the agent will know how to sort of navigate the problem, right? So then you would use this function to sort of render it with the input, like the specific input. You can pass in the question, right? So this will actually just update this prompt with the particular input that the user has. So, right, okay, and then so here's where the code executor is. Now you can set up, you need a local command line executor, which we imported here. So this is where your code is executed. So from AutoGen coding, there's like there's a class called local command line executor, and that will handle that will handle parts where you need to execute code, right? So when you have code that is returned from your from the LLM, you can execute it in that using this instantiation, and you give it a working directory. And here's the user proxy, right? And then in the user proxy agent, so we have given it a name as user, and then we have given a function that tells it when it needs to stop, right? So we when the LLM says terminate, then we know that the whole conversation needs to end, and that is defined here, right? So there's an assistant agent here, and we give it a system message saying that only use the tools you have been provided with, and reply terminate when the task is done. So when this terminate keyword is returned from the assistant agent, then the user proxy will, since we have this termination logic, it will terminate when the response ends with terminate, right? So here we also set the human input mode as always. So it will always stop whenever the user proxy is triggered. It will always wait for our response. And then we also mentioned how many auto replies can it go. And here's the code executor that we've passed in as well. So I'm quickly going to go through this. And here's the assistant agent, and we've given it an LLM configuration, right? So that is where we defined earlier the config list. So it has access to different LLM models, and it will, since we've already only given it one, it will use that model. But if you given multiple models, it will use all of those. I mean, if one of those models are not working, it will select the other model. So there's no particular way. So AutoGen handles that on its own. You just need to pass in the configuration list, and you can do filtering, but it does it all automatically for you once you provide the configuration list. And you'll also register the function. So if you have a bunch of different tools, you'll need to use this register function from AutoGen, right? So AutoGen has the register function. You can use that to register all your tools with the agents or with the conversation, and then you'll use a search tool, and then you can mention who the caller is. So assistant is the one who will be calling it, and where the person who will be executing it will be the user proxy. That is the agent that will be acting on behalf of us. And then you have a name for it as well as a description, right? So I'm going to go ahead and run this, right? So I just ask, is IIT Sri Lanka situated in Colombo? It's just a random question. So, and then that question will be wrapped around the React template that prompt template that we gave earlier. And then you can see that the assistant has responded that I need to find the location of IIT Sri Lanka. So the action will be search the web for the location of IIT Sri Lanka. And the input for that action is IIT Sri Lanka location. And the observation is so on and so on. I keep on doing that. So it had basically already determined, maybe it had the information on its own. So it has determined that the final answer is that yes, IIT Sri Lanka is situated in Colombo. So here it's waiting for user response. It's waiting for input. So you can go ahead and say, you can type in any information you want. And if you just want to let it go automatically, you can just hit enter. And it'll just go for auto reply. And auto reply is it would just send in a blank message, right? Since it's just nothing, it's just you use a proxy. And then it says that the assistant will now respond with say that no further questions have been provided. It'll respond with terminate, right? So if you do not, since there's terminate in this, we have the termination logic. The whole process will end, right? So it will determine that the action has been taken place. You can see that you can use AutoGen and you can define different assist. Now, this is just a simple use case where I define only a single assistant agent. You can go ahead and define other agents and then have more than one agent, maybe define a whole team of agents and have them working in concert together, right? So I also have an example below. So teachability is where you provide memory to these agents. I'm not going to execute that. And here is another small example where you can define a conversable agent. And so we define a student agent where the system message is you are a student willing to learn, and you provide it with the LLM configuration. So it has access to the LLM. And then you have a teacher agent that we give it a name, and then we define the system message to be you are a math teacher, and as well as the LLM config. And then from the student, we would initiate a chat, and then maybe pass in, and we would initiate a chat with teacher agent, and then we would ask what is the triangle inequality, right? So then there'll be like the student agent will ask the teacher agent what is the triangle inequality, and then the teacher agent will respond to that. It will respond here the triangle inequality or so on with the information. So since there's no user proxy here, you are not in part of the conversation. The student agent is having a conversation with the teacher agent, right? So the student agent is asking, thank you for explaining it. And then it's going ahead and asking some other information. And this conversation will keep on going, right? So that's basically it about AutoGen. And I know it was pretty fast and it might have been a lot of information. But I highly recommend that you go through the documentations and then read through them to understand what specific use cases that you can go ahead with. So this is just like a brief introduction into the frameworks that are out there, right? So that sums it up for the frameworks that you can use in different applications. So Langshan is pretty interesting. You can use that. And you have, once again, you have AutoGen where you can have a multi-agent setting. So there's others like Crew AI, and there's Llama Index for communicating with databases, with documents, PDFs, and so on. So I guess we can move on to the next session. So we are kind of running out of time as well, Hansa. But Sasanka, is it okay if we continue?
Yeah, fine.
Okay. Right. So we'll. I think this will be another good point to stop in and answer some of the questions that you have.
Can we check like how much time we actually have left, or if we even have any time left?
Yeah.
Do we have any, like how much time do we have left?
You could take additional 10-15 minutes, but shall we continue the session and have the Q&A at the end?
Okay.
Right.
Yeah.
Right. Let's do that.
Yep. Okay. In that case, Sachit, I'll take over and try to finish it in like 50 minutes.
Yeah, I think we'll just stick to the implementation part to a minimum, right?
Okay.
Or shall we skip the combining part? We'll just go through it very fast and then go to the implementation.
I'll just go through it really fast. Okay, let me just share my screen really quickly. Okay, combining tools with LLMs. Okay, let me just quickly go through the exploring some common types of tools. I think Sachit, to be honest, covered most of these, like when in his demo, like the web search tool and stuff. So in this section, basically, we're trying to explain like LLMs and like some of the common tools. So there's like web tools, then there's REST APIs. You can connect them via tools, and then databases, and how you'd connect them to like real world like applications and stuff. So when it comes to web, we highlight that you can use something like Beautiful Soup and Cheerio to actually get the web content, parse it into something that LLMs can understand, and then use that content to actually browse the web. So it's actually just web scraping. REST, in terms of REST APIs, you just have to like write the REST API logic in the tools, and then like you can make the REST API calls like in the calling tool. So there's nothing really much to that one. And then in terms of databases, so the LLM is going to basically create the SQL query, and then you can execute it using something like SQL Alchemy. So like pretty trivial. You just run the SQL query that the LLM generates, and then you get the data back from the database via like SQL Alchemy, and that's kind of the entire loop for databases. For like LLMs in the physical world, you probably have like a controller that's controlling something, and that also could be like a REST API call or some kind of like communication mechanism. It's like very similar to IoT. So like any IoT mechanism really just applies here. So that's that one. In terms of like connecting it to a compiler, but since it's already running on a code level, you could run on the same runtime. or you can like find another runtime. Like even if you want to run on a Python runtime, you create a Python runtime and then you run it on that. Or like you just have to find the runtime and then take the code that the LLM generates and then execute it on that runtime. Yeah, so that's kind of like the LLM compile thing. And then once you compile it, run it and everything, you give that output back to the LLM and it can just run in a loop, like very similar to like the demo we went through. And yeah, that's just the slides. I think I have about 10 minutes left, so I'll just get to the code really fast. So I'm not gonna code it from scratch. So I'm just gonna show the examples and we'll maybe like move on to the questions maybe really quickly, just running through everything. So this is the first example is basically, okay, wait, we'll start from here. So in the implementation, I wanted to kind of start off with like how we can first get like LLMs working on light LLM and stuff. So here we have like the LLM base, and in this one, it just let me just run this really quick. I feel like that's the easiest way to actually show what's going on. So let me just run through this. Right. So running the first example. Okay, so what I'm basically showing here is like how you can communicate the LLMs via like a streaming like mechanism. And from this LLM base, you're basically going to be building off into like some of the more other complicated ones. Like in example 2, we start adding memory to this. So like that means the LLM will be able to kind of remember what the messages that we're giving it. So in this example, we're saying, hi, my name is Bob. What's my name? We're asking it again, and it should be able to kind of answer our question. So here, let me just run through this. So you can see, yeah, you must be Bob. Okay, and then you can see like it figured out that our name is Bob. Okay, next one. That's example 2. Moving on to example 3. Here, this is where we're kind of adding in, we're moving from streaming with like memory, right? When we're adding like function calling on top of that. So I'm gonna spend like a little bit extra time on this one since it's like the part where like most of the explaining actually needs to happen. Okay, so let me just start from over here. So this is the agent class, right? So the agent class will take in tools, models, and also a callback function. And like with all these things, we're gonna be like making the functionality for the like agent to run, like defining what tools it needs, and then the callback kind of shows how the user kind of gets the output. Yeah, so the completion logic from this initial thing is over here. So just to make that completion call, this function is there. And going down here, for agents, we have run and we have run iteration, right? So in the previous examples, you only had that run function, which basically just runs it, right? But in agents, you have that agent loop, right? And that agent loop is kind of defined here. It's this while true. And then we're checking if it's not a tool call, we kind of want to just break out of it. If it's just responding, we just want to break out of it and actually just go about like answering questions and stuff. So in this run iteration thing is where like one iteration actually runs, and in the run is where the agent loop kind of runs. So for the agent loop, what we do in streaming is, like I mentioned earlier, we're going to be collecting the messages and the tool calls in 2 separate lists, right? So if we go into like process response, we are going to create a LLM like call, right? And then that we're taking the response, and then we're taking apart the stream as it's coming along. And what actually happens there is if it's a tool call, if it's a tool call, we call this handle tool call part. And if it's a normal message, we handle it in this handle content delta function over here. So if it's tool call, we handle it here. If it's like content, normal content, we just handle it here. And once it gives the finish reason, we can actually break out of this loop and actually process the thing. So this is not processing it. This is kind of adding it into those little bins that we talked about earlier. And then once we have it in those little like bins, what we can do is like handle the content data. So this content data is handled here. And it's pretty trivial. You just send it to the user. And tool calls, on the other hand, you have to handle it a bit more like specially, because over here we need to get like the function name and the role and like what the tool is and everything. And we had to send it to the callback function. But essentially what we like kind of do here is like we parse out the tool's calling logic from the stream, and then at the end we want to actually send it off to the execute calls, tool calls part over here to actually execute the thing. So we parse it for here, and then once we have the parsed information, we send it to the execute like part here, right? We can actually execute the thing. So if it's a async function, we execute it async here. If it's a normal function, we execute it here. So we find the tool by the name, and like from the like tool call like arguments that we get. And once we have everything, we just execute it here. And then once we have the response, we actually just append it as like a message and send it back. And yeah, that's kind of like it. Basically, you send it back, and then it can run like another iteration and then reply. Yeah. So that's that one. Let me just run the example really fast. And example number 4, it's just adding a tool call memory type thing. So, and we actually looked at that earlier, so we don't have to like look at it again. But you can kind of see it's making the tool calls, and you can see like it's giving the final output here. It's printed like line by line, but if we add like a proper callback function, I think you should be able to. Yeah, no, it's okay. We won't add that right now. Okay, I'm just gonna stop, go back to the presentation really quickly. I think that's it from my side. We can answer any questions, Sachith.
Yeah, so we were kind of planning to implement the examples that Hansa just shared. We were planning to sort of implement it during the session, just he ran a little bit out of time. I guess we can share the code base with the
definitely share.
We can share the code base with you, and obviously we can leave our emails, and you can get in touch with us if there's anything that you want to know. We can obviously help. And like I mentioned, the last part that we really wanted to show is what really goes underneath these frameworks, although we could do it. But since we mentioned a little bit about frameworks, obviously when you're building applications of your own, you'll be using frameworks that are out there, or you can build it on your own. But using the frameworks is quite easy, like we mentioned. And customizing it, that's where you'll need the expertise in tweaking all the codes, right? So we've shared all the resources. We'll share the code base as well. And we'll send this over to Sasanka as well, all of this information, and then all the resources. And all the team can share it with you guys, and you can get back to us if there's anything needed. So highly recommend looking at if you're using a framework or any other tools that are out there, get used to reading those resources or the documentation and then using them. So if we would have stick to explaining a single framework, that wouldn't be really intuitive on how to use other frameworks. So it's pretty easy. Just go ahead looking at those documentations. There's like a starting point in the notebook that I've shared in the chat. So that's like where you can create a simple React agent, and that can be customized to your needs, right? You can define different tools. You can use tools that are already there and then customize it. That's just one way of building it. So we'll also share some resources from Langshan itself and LangGraph, and they have a pretty neat introduction into their way of solving the agentic problems. Right. So let's go ahead and answer the questions. Sasaga, can you bring the? Do you have those questions in your slide deck, or should we share the screen and answer the questions in Slido? How do we do that?
Excuse me.
Yes.
Can I know we can use Llama index instead of this LangChain and AutoGen for this agent making?
Yeah, I mean, like I said, it's pretty. We can use any framework that you're comfortable with. You just strictly don't have to like stick with one thing, right? So we just introduced LangChain and AutoGen here, but Llama Index, AI, those are the things that come into mind. You can use those based on your use case, and that's why we didn't want to stick to explaining a framework at once. But if that's the use case that you need to use, of course you can use. And Llama Index has a lot of built-in support for vector stores, right? If you're familiar with it. It has built-in functionality for communicating with documents, SQL databases, and so on, right? So to sum it up, yeah, you can use any framework that's out there. It's pretty much your use case. Any other questions? Let me just see if there's anything on Slido.
Yeah,
All
we
right, so
share
there's
the slide.
sorry, Sasaga. Okay, there's a bunch of different questions. Okay, so I think so. Hansa and I will kind of like jointly answer these questions. So, can you explain how semantics works in LLMs?
Depends. What does semantics mean in this?
Exactly.
Yeah.
See, if the person who asked this question is still in the meeting, can you kind of like elaborate on what you really mean when you say semantics?
I
Because
guess
it
they can
depends on.
message on the chat.
Yeah.
We'll move on to like the other questions till then.
Yeah. So if the person is still there, you can go ahead and follow up on that question so we can answer that question. So the next question, what about fine-tuning existing open source LLM with a data set which contains higher context length than recommend context length on that LLM, right? So yes, you can do that. You can fine-tune I'm not pretty sure during which context, during which part of the session this question was answered into, but yes, there's a bunch of different research that's going on where you use the existing LLMs and then you fine-tuning with higher context lengths to fine-tune it. And then you can also change the architecture if you want. You can add in different LoRa weights into it and then fine-tune it for longer context as well, and then use that for your use case. I think this question was asked in where I mentioned that you wouldn't plug in your whole PDF directly into the model. I think that's what it was, I guess. Right, Hansa?
Oh wait, we gotta reply on that last question. Semantics in the sense how LLMs capture the meaning of words. Like embeddings, semantics in the sense meaning of words. What's the original question, Sachin?
Yes, can we see the original question as well along with it? Okay, so you're asking like, how does it really capture the meaning of words, right? So now for that, that's pretty much not related to agents. It's much more of like how attention works, I think, if that's what you're talking about. So here,
It's the initial layers, right, where they generate like the word
embeddings.
things, and then so that's how you convert like tokens into meaning for the LLM, and then you feed those vector embeddings into the LLM, and like within attention, it actually makes sense out of it.
So if you really want to know how it works underneath, adding on to what Hansa mentioned, so you would basically, if you take a simple sentence, right? You can break that sentence into different tokens. You wouldn't, and if you're familiar with how LLMs really work, they don't really work in a word level, they work in a token level. So there's different tokenizers trained, and you can break this whole sentence or whatever prompt that you have, you break it down into different tokens. And then you would also get embeddings for each of those tokens, right? And then you can use this embeddings to find out how each token relates to one another in that particular prompt, and then see the attention that it has with each other. Now, this is actually going towards the fundamental part of LLMs, right? And that's how it really identifies how to respond to that particular prompt. And then it would identify how each token relates to one another, and then responds accordingly.
Okay, I think we'll go to the next ones.
Yeah. So in stock management, always database update when we create agent for that, how to use reg.
Oh,
database.
real time. You know, this one, what we can actually do is like I showed that your brain runs in bursts part, right? So that's kind of how you manage real-time data. So if you're like doing this, it's kind of how you do like live code changes and stuff, right? So you make a change, and then you update the memory inside the agent to actually reflect the real-time data, and this happens in bursts. So technically it's not real time, but every time you send a request, you update the data, and then in like the messages you're sending. So that's as real time as you'll get, right?
Yeah. So yeah, I mean, so I think for stock, when it comes to stock management, I think this question aligns with how real-time data really comes in, right? So you wouldn't always have it in the database, so you would get that information, like Hansa mentioned. You can get it as it happens. You can have it as you go, right? Maybe have an API call, not have it always in a database.
Okay, next question, I guess.
How can we get the resources, notebooks, and slides? So some of the I shared the notebook that I was doing. I shared it in the chat here, and I'll the slides and all of those stuff we can. Sasanka, do you have? I mean, the participants here today. Is there a way that you can communicate with them later on?
Yeah, we already have a delegate WhatsApp group, so we can form.
Okay, then we can share all our slides and the Colab notebooks and the code base with you, and then you can go ahead and share it with them, right? Okay, perfect. So I think yes, you can do agents with JavaScript. You don't necessarily have to learn Python because if LangChain does have a JavaScript API as well, so it has a JavaScript library, and the framework is built there. So you can use LangChain with JavaScript. So you can do that there. You just don't necessarily have to stick to Python. Just that. Yeah, go ahead, Hansa.
Oh no, I was thinking there's this framework in mind that's not coming to my head, but on the front end, you can kind of do LLMs as well using this framework. I can't remember the framework, but yeah, I think it's LangChain.
Yeah, because LangChain does have a JavaScript built as well, so you can use that.
You probably don't want to be actually making agents in JavaScript because there's a lot of like limitations with that, especially like if you're improving the functionality in the future. And if you are going with some like JavaScript framework, you need to make sure like it's like maintained properly, and it's like
Yeah.
like LangChain might work, but not recommended, I'd say, from our end.
Yeah. It would be one more thing is it would be much more easier in Python
Yeah.
when it comes to implementing, because there's like where at least when there's like intercommunication with other things like ML models or some things, Python would be the best way to go, because that's where you sort of stick with AI and ML, right?
Yeah.
Okay, so I think that's all that we have. For questions, I think I answered the one on the top. Right. So if there's no other questions, I think we can conclude the session. And if there's any, you can go ahead and send them over. Right then. Okay, Sasanka, you can go ahead and conclude the session. I think that's it. If there's anything, just go ahead, and you guys have our emails. You can send anything you want to ask, or anything related to the resources, go ahead and ask us.
Thank you, Mr. Gunasekara and Ms. Naurunna, for that insightful presentation. Before we conclude, we would like to express our heartfelt gratitude to Mr. Gunasekara and Ms. Naurunna for sharing their knowledge with us. We invite you both to accept our token of appreciation for your invaluable contribution to making this session a success.
Thank you.
Now, we would also like to capture this moment with a group photo. Please turn on your camera and join us for a quick snapshot. I'll wait for a few seconds till the others turn on their cameras. Okay. So on the count on 3, 2, 1, just pause well so that we can capture the screenshot. 3, 2, 1. Thank you so much. Okay. Thank you all. We have now come to end of today's session. Once again, thank you for joining us this morning. We hope you found the session both informative and inspiring. We will share the selection round details in the delegate group. Stay tuned for future events and updates from our community. Have a wonderful day, and we look forward to seeing you at our next event. Thank you.